In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played a tune that echoed.
You got to do an updated one now that they're there.
The
Yo. Mic check.
Yep, you're good.
All right, cool. All right, so we are gathered here today to learn about Aries failure, a time in history when a man put water in a telescope and tried to measure the deflection angle that would be caused due to Earth's orbital velocity. So this goes all the way back to 1871 from Aries, which is titled "On a Supposed Alteration in the Amount of Astronomical Aberration of Light Produced by the Passage of Light Through a Considerable Thickness of Refracting Medium." So we're going to get into what all that exactly means and why he did it. But before we do that, we're going to learn a couple of prerequisites about the experiment and the measurement so we can understand the entire scope of the process. So the units of measurement that are going to be used here are called arc seconds. If you look at a protractor and you take the distance between 1 and 2 degrees and you were to break that up into equal sections, you can break it up into 60 sections, and that would be 60 minutes per 1 degree. So 60 minutes makes an hour. That would be 1 degree, right? So you can think of a degree as an hour, and then minutes to an hour. And then every minute has 60 seconds. So you can actually break up the distance between 1 and 2 degrees to 1/3600th of a degree. That's pretty precise. And then, of course, we have milliarcs and microarcs, and that gets into astronomical observations that are done at altitude where there's less refraction, they say, and they can get these precise measurements. We're not going to be dealing in that scale, but that's the full context of how the measurements work for astronomy. We'll get into some observational conditions now. So this is from McRobert from Sky and Telescope magazine, who's saying that viewed from the bottom of an ocean, a star is a living thing that jumps and quivers and ripples tirelessly, or it swells into a steady ball of fuzz. And we've all seen the videos from Taylor where we can see that steady ball of fuzz. We've seen, more refined images of them and stuff. But the point being is that they're always fluctuating due to atmospheric conditions. And then he goes on to say that no matter how perfect the optics you have for the aperture or anything like that, it doesn't matter. The best you can resolve from the ground is 1 arc second. And that is if you're doing a direct 90-degree zenith observation where you're going to have where your angle of incidence is going to be, less in regards to the medium that the light is traveling through. So at an angle, you're traveling through more atmosphere, so you get more of an effect, basically. And then it says, more typically at ordinary locations is the 2 to 3 arc second of viewing. So on that scale, it's usually quite larger than 1 arc second. Now, the next thing to note is we're going to be talking about true positions and apparent positions. Now, this is really important because to even entertain the idea of stellar aberration, we're going to give like a benefit of the doubt to the position that there's a true position of a star and that there's a deviation from that and that's supposed to be meaningful. So what this means basically is every object, including the sun and the moon, like regardless of distance, if it's in the sky, it suffers from an apparent location. And actually, everything is kind of an apparent location, just to varying degrees of how much that's going to impact you. But in regards to objects, celestial bodies specifically, everything is in apparent position. So what that would mean is, the star would actually be right here, but due to refraction, you would see it in a different position. And these angles are exaggerated to give, clarity to the example. Now, in regards to a true position, we have what's called the first cusp of Aries. And what that is that's the position of the stars in the night sky during the vernal equinox. And you can think of it like taking a snapshot of the stars, and then you basically just wait a year, you make a year of observations, and eventually those stars will return to their original position that you took that snapshot. And what you're going to be looking for is deviations to that, to their return, right? Now, because everything in the sky is constantly moving and we only see an apparent location, the quote unquote true position is arbitrarily defined. And that's why giving credence to this as proof of heliocentrism is, a big, benefit of the doubt. Like, I'll give you, I'll accept that argument so that we can, explore it further and see what we can get out of it. Okay. There's not an actual true position of these stars. This is all a snapshot based off a specific time of year and when the stars return to that. And then they take a ratio of a deviation from that snapshot. And they say that ratio against the speed of light comes out to 30 kilometers a second. And that's what they're interpreting as, the causal mechanism of that deviation as being Earth's motion. But we'll get to that as we continue on. But this is just setting the full understanding of what's being put forward. Now, how do we explain this on a flat Earth? Because this observation of stellar aberration is actually a dual evidence for the globe and for heliocentrism. Someone's hot micing, please.
Okay.
All right. So let's see here. Yeah. So on a flat Earth, how I think the sky works is that there's a toroidal field and the stars are projected on that. And when we get to the equator, we see the divergence of the two star fields going in their respective hemispheres. That, in combination with the limit of your vision, will provide the necessary observations relative to the hemisphere. And then if you were to map that on a coordinate system that you could use to project over different types of map projections, like a Mercator or an AE map, etc., you would merge these two hemispheres with a spherical coordinate system, with the northern hemisphere represented by positive values and the southern hemisphere represented by negative values. And the equivalence between the stars completing a circuit above your head and reaching the limit of your vision and appearing to set into the horizon, or being on a ball and rotating away from the stars, and there's optical curvature. And there's physical Earth curvature to cause the obstruction. Those become equivalent. So the stars going beneath your feet and coming up around you and completing a circuit above you, being projected into your grid of vision, are equivalent. So that's how we would explain the latitude dependent deviations, because in the same respect, as you get closer to the North Pole, you see that the stars complete a more tight circle. And as you get further out, they start making an ellipse shape all the way down to a straight line at the equator. Now, they say that on the globe, because the starlight is coming in parallel, that these latitude dependent effects are due to the contour of the Earth. Whereas my flat Earth position is that this is just an optical phenomenon due to the star field being projected on toroidal geometry. All right. All right, so I was talking about the equivalence between those coordinate systems. So just kind of to give some visualizations to what I was talking about, you would be an observer here in the center of this intersection of a fundamental plane. You would have the sky, the objects in the sky would arc above you, and they would appear to set into the ground or the horizon where everything converges. And when things go out of view, whether or not they're completing a circuit above you or going beneath your feet and coming up behind you, that would be the optical equivalence. And then on the underside of this, for the southern hemisphere, that's the representation that you would be looking at there. All right, and then just another shot of two hemispheres being merged. So we have in the north, you would see this. In the south, you would see this alignment, and to merge these together in a coordinate system, that would be the coordinate system that we're all familiar with, that gives the, that best fits the globe because it's a spherical coordinate system, but it can be projected out into other coordinate other projections that all represent the exact same thing. So what the first cusp of Aries would look like on an AE, an azimuthal projection, it would be just like this. You would have your outward concentric circles, and your map of the sky would go as follows. So there's a direct equivalence there. So we can continue on now. Now, is there any questions so far? All right, go ahead.
Do, but keep going.
Okay. All right. So a big point of contention that I saw in Aries failure as I've been presenting this and looking into it and the modern refutations and whatnot is a misinterpretation of the speed of light in a medium. Some people will argue that the speed of light is the same, therefore there's no difference, but then they'll say, well, it takes a different path in the medium, and due to that path change, that's what's causing the difference, but the speed is still the same. And there's no difference between those two explanations. If there's a path length change, there has to be a timing difference, which is the key pivotal part, which is all that really matters. So if we can both agree that irrespective of how you interpret the velocity of light in a medium, there's going to be a timing difference. And if you disagree with that part of it, because that's the actual point of contention, that there would be no timing difference. So we're going to watch an experiment done by this lady called Through the Looking Glass or Looking Glass Universe, something like that. Anyway, she uses a laser meter and a container filled with water to measure the distance based off of the time of the speed of light. She measures it in air and in water, and she gets a timing difference in the water, which increases the distance read by 30%, showing that the speed of light does indeed slow down in water. So we'll go ahead and watch that.
Okay, it gives me 11.2 centimeters. If the old distance is like 11 centimeters, then the new distance should be approximately something around 14.5. Okay, so if the result is like approximately 11 centimeters, then that means that the speed of light in water is about the same, whereas if it's about 14.5, then it means that the speed is significantly slower. So let's see.
Now, before we continue, she's a PhD in quantum mechanics. She's the same woman that did the double slit experiment at home during the lockdowns with a fog machine and showed that the diffraction pattern of a wave is consistent throughout the entirety of the experiment. And at no point is there any wave particle duality. And anyway, when she went to start this experiment, her hypothesis was that she knew that, she had been told that the speed of light slows down in a medium, but she had never really believed in that, had never really conceptualized it like that, and how she couldn't really rectify that with Einstein's theory of a constancy. So she comes up with this convoluted way to gaslight herself with math. And she's like, yeah, I definitely can prove that it would be the same in the medium and blah, blah, blah. So this is about to be pivotal moment in her, assuming that this is all like a authentic video or whatever. So this is about to be, a very important experiment for her. So her prediction was that there would be no change in the distance that she's about to measure.
Okay. Aiming it for about the same spot and okay. I think that's a
What's she
positive
using?
result.
What's that thing? You know what it's called?
Yep, it's a laser meter. And there's two different
Laser
types.
meter.
Yep, there's two different types. One that does a group velocity and one that does a phase velocity off of a pulse or something like that. And some people in her comments were saying, oh, you have to do it with a different device because this device is, wrong or whatever for some reason. So she goes and does it with the other type and it gives the same exact result as well. But yeah, it's called a laser meter.
Cool.
So I've been thinking about maybe whether this doesn't work the way that I think it does. So it turns out there are two types of LiDAR. There is one that's called...
Yep. So anyway, she goes on to talk about all that. I'll leave a link here in the description if you guys want to watch her full journey there. I just gave a truncated recap so we could get the full quick TLDR. And moving forward, we now know that in a medium, the speed of light changes, which, is measured by a timing difference. Okay. So throughout the history of heliocentrism and sky observations and whatnot, we have the phenomenon called stellar parallax. And this is a change in the position of the stars with respect to their, so-called true positions throughout the year. And it's put forward that this is due to Earth's motion. And if you use the baseline of the triangle as Earth and the distance to the sun, so 93 million miles for the first 6 months of the year, and then another 93 million miles for the latter 6 months, you add those two together, you get a baseline of 196 million miles. And then we have the stars that converge at basically infinity. This diagram gives the impression of a clean triangle, but these are actually more like parallel lines that deviate, at 89.9999999999999 degrees that, trust us, bro, converge at a point at infinity. But anyway, that's neither here nor there. There's a geocentric equivalent for this observation where the baseline is the movement of the stars and the triangle converges at the observer on on Earth. So that's a direct equivalence with the triangles. So in other words, this measurement alone cannot tell us if the Earth is in motion or if the stars are in motion. It can't distinguish. We don't know. It's not mutually exclusive. Now, here we have some incriminating evidence from 1943 from the Dearborn Observatory, where this lab writes in and he's like, hey, I measured negative parallax. So in other words, in heliocentrism, if the parallax is caused by the motion of the sun, if the parallax is caused by the motion of the Earth around the sun, it all has to be going in a specific direction. If you have negative parallax, that means that the star is going in the opposite direction. And that would indicate that the causal mechanism of the parallax has nothing to do with Earth's motion, and it would actually refute it, because if it goes in the opposite direction, then that's not, optically possible. So this guy's like, hey, what doth thou do when thine is experiencing negative parallax? And the answer is given here in three tiers. Tier 1, in the case of real parallax, you can just do a statistical analysis because you're assuming the correctness of heliocentrism. You can assume that this is a observational error, and you can use mathematics derived from Sir Frank Dyson, who is the mathematical fixer for Eddington's observations. You can just apply his statistical analysis, and anything that's going in the wrong direction, you can just go ahead and treat that as going in the correct direction, as long as it's not too big. And if it's too big, you can just assume that it's a binary star system, and due to the gravitational anomaly between them, because like, you know, they're going to be traveling faster, there's going to be a luminosity brightness issue, and you can just, you know, go ahead and chalk that up as a positive as well. And then suppose it's too far in the wrong direction that even that doesn't work. Well, what we can just assume is that the reference star moved, and we just have to use a different star now. Oh, no way. You can just do that. Okay. Well, that's unfalsifiable now and completely insane. But that's the protocol to interpret the sky when you make an observation that falsifies the model. You just reinterpret it as a proof of the model. All right. So after parallax, go ahead.
I just feel like that's like a major point that I want to. They changed the stars or something?
Yeah, so the reference stars, like the fixed stars, the background stars that they say, that they would do the comparison for the stars that have the parallax. They say that if it goes in the wrong direction, that perhaps that reference star actually moved, and you should just use a different reference star.
Okay, so one of the stars, yeah, what you said, it falsifies what they've been saying, but they just ignore it.
Yeah, and they're just like, just use a different reference point that gives the agreement, that makes it positive. Because yeah, it's
okay.
dude, it's insane.
So I thought the stars didn't have parallax, but okay. Anyway,
reindeer reification.
Yeah, but it's a slippery slope anomaly fallacy or whatever. But I'm just anyway.
Okay,
so
I just wanted to understand that point.
No, you're good. You're good. So after parallax was introduced, they were taking their measurements. There was this additional observation made by James Bradley in 1727 called stellar aberration. And this is where he has a telescope with a zenith mount. And so he's looking directly 90 degrees at a star called Gamma Draconis. That's over London, jolly old England. And he notices that he can't quite get the star in the center crosshair of his telescope. He has to, it's always ahead a little bit. And by the amount that it's ahead over the course of a year, if you plot that out, it makes a 20 arc second difference from the predicted, true position where that star should be in his crosshair at that zenith. 1 second. I'm going to get some water. So when you plot that out, like I was saying, that 20 point whatever, it's like 20.56 arc seconds, something like that. When you ratio the arctan of that over the speed of light, over the velocity of the Earth over the speed of light, you get the theta angle here, which is 20 arc seconds. So the people that were taking this observation were like, "Oh my God, no way! We just confirmed Earth's orbital velocity because of this ratio." Right? So they measured an angle, and then they backwards derived what the angle would be based off of the velocity of light and the assumed velocity of Earth. And that's pretty cool, right? That's pretty substantial. That sounds incredible, especially if you give the benefit of the doubt to the true position. You're like, God dang, that sounds awesome. And then, of course, here in the diagram to show you that latitude dependent effect I was talking about, that would be considered like a double proof for the globe. You would have circles at the North Pole, and then it would converge to ellipses until you get to the equator, where it just becomes a straight line. But anyway, the more important part is that these parallel light rays are coming straight down to the Earth, and the Earth is moving out from underneath it, and that's causing a deviation angle, and that the ratio of that angle over the speed of light is the gives the velocity of the Earth. You could backwards derive it that way. So that's so they were all, you know, blown away by that. And again, that's giving them maximum benefit of the doubt that there's a true position of the star for this deviation to even occur from. So now we're going to get into a couple of experiments that were done to actually test this hypothesis, right? Because like I was saying earlier, the measurement alone, the observation alone is just a measurement. The measurement alone is, you know, that's just kinematics. It can't tell you if the sky is moving or if the Earth's moving. Your relative motion is equal in both of those. There's no dynamic asymmetry in the system. So we, you know, no manipulation of any independent variables have occurred. So we can't affect the dependent variable, which would be the aberration, right? We haven't done anything yet to affect that. Okay, so starting with the first one, we have Arago between 1810 and 1818. He had hypothesized that due to Earth's motion, you know, going with and against the stars as you go perihelion and aphelion throughout the year, that you would have to adjust the focal length of your telescope to compensate for that velocity difference of going towards or away from the stars. And what he found was that you didn't have to make any adjustments. Now that's a manipulation of the independent variable, the focal length. So that's like step one, you know, but that's not very conclusive, right? Like you could maybe argue that, you know, the distances and the speeds, you're not going to expect much of a difference. It's all going to be more or less the same. It's like, okay, fair enough. But that was step one. Step two, Arago comes back in 1853, and this time he half covers his telescope with a crystal prism. And again, this is a Zenith telescope, but in the diagram here, it's tilted just because I didn't know that at the time. But anyway, this is a Zenith telescope. And what he has here is he's looking at starlight. And when the star intersects the center of the telescope as it transits, he's either going to have to adjust the telescope to keep the star in the center, or the star is going to remain in the center irrespective of the medium change, which would mean that the starlight already comes in at that angle. That you could interpret that as that the Earth is stationary and that the starlight is coming in at an angle. So what he found was when that star intersects with the crystal prism in the center of the telescope, he did not have to alter the position of the telescope to compensate for that. And we have a quote here from E.T. Whitaker, a lad from back in the day in 1910. He states, Arago submitted the matter to the test of experiment and concluded that the light coming from the stars behaves in all cases of reflection and refraction precisely as if it would if the star were situated in the place which it appears to occupy in consequence of aberration, meaning in consequence of Earth's motion, and the Earth were at rest. So the apparent refraction in a moving prism is equal to the absolute refraction in a fixed prism. In other words, the light already comes in at that angle and the Earth is at rest.
Say it ain't so.
I mean, it can't get any more straightforward than that. But we'll continue. So now we're going to introduce a little.
Are you saying
Go ahead.
the prism? Does the light have to be in the center? Like, what's the prism? It just.
Yeah. So when the light hits the medium, it's going to travel slower. And if the Earth is in motion while the light coming through the prism is traveling slower, the Earth is going to travel further out from underneath it, and it's going to cause it to be no longer in the center of the telescope.
Yeah.
But
so is the prism just like, it's more, how do I say this? Like, it has to be spot on more, like more precise.
It's just,
I don't know.
Yeah, no, you're good. It's just adding a medium to slow the speed of light so that you can determine, because in the variable for stellar aberration, right, we have two components. We have the angle, and we have the velocity of the Earth, and we have the velocity of light. Now we can't change the velocity of Earth, you know, assuming that that it has a velocity. You're not able to alter that. But what you can do is you can slow the speed of light. So if you introduce a medium to light that's coming through this telescope and it gets slowed down here, the Earth has more time to move further, which is going to increase the angle that occurs. So to keep the star in the center of the telescope, when it hits this point between air and the medium, if the Earth is moving, you're going to have to adjust the telescope to compensate for that. Does that make sense?
I get the water in the telescope to slow down the water, but the crystal... Oh no, I'm probably just overthinking this.
No, you're good. It's the exact same concept. Just imagine this is a giant crystal that fills the telescope. Same exact thing.
Oh, so okay. So the water in it's the same thing.
Yep.
Okay. Oh, good. Sorry, don't want to interrupt.
Oh no, you're completely good, man. Any questions you have, this is for the boys, man. So anyone that, you know,
because I thought he had water and the prism on his telescope.
No. This was a guy named Arago who did this before Aries. This was the first guy that did it. He's a famous French physicist and astronomer from back in the day. His name is Francois Arago.
Water and prism?
No,
he just had a prism.
He just had the prism. So he was using air and a prism.
Okay.
And the way he was doing the observation, right? So half covering it with air, you're going to have like the same normal amount. At the midpoint, you're going to see the star there. And then when it hits the crystal prism, it's going to get deflected further. So you're going to have to adjust the portion of the part that's going through the crystal prism. But if you don't have to adjust it, then that means that the starlight is already coming in at that angle and you're just stationary. Because there's no distance change.
Arago's.
Yep.
It was Arago's experiment. I'll just look into it a bit more.
Yeah, Google it. It's called Arago's crystal prism experiment. That'd be the best way to find it. But I have the title here in French. I'll post it in chat. You can ChatGPT translate it or whatever, and then look it up. But yeah, that's what he did there. You can find more information about it on Google.
Cool, thanks.
Yep. And then we have Fresnel drag. So now we're going to be introducing a little interferometric measurement here. And this is going to be extremely relevant as to why these people were adding mediums to their telescopes here. Because it was experimentally shown that you could measure the translational velocity of a moving medium with light. So what they did in the case of Fresnel drag, a guy named Fizeau in 1952 or 53 did an interferometry experiment where he split a beam of light through a beam splitter that goes through a rectangle tube of water, where the light beam that's split can go with and against the flow of the water before it gets recombined. And using the speed of light and the refractive index of water, what he found is that independent of the refractive index, there's an additional 44% velocity boost and reduction to the measured speed of light in the fringe shift patterns, totaling 88% of the velocity of the moving water. So they measured 44% of that velocity going with and 44% going against. Now this is extremely significant because the hypothesis here was that the ether the static ether that they conceptualized was a material medium, and that it could be dragged by another material medium. So this was experimental confirmation of that. And the relative density of the ether in the refractive index would be is equal to the refractive index squared. And that was all Fresnel's hypothesis that was derived in 1818. So even back then they had, an accurate way to interpret light through fringe shift readings to derive like refractive properties based off of the fringes that they would get when they would introduce light to a transparent medium. This is how they took all these measurements. So when they had these values and plugged them in and did the experiment, they measured the speed of light that, as it recombined, going with and against the velocity of the water. They measured a timing difference that was directly proportional to the velocity of the water, or well, to the tune of 88%. Anyway. So the idea that they're going to move forward with, especially in Aries and Klinkerfues, is that if you have a telescope filled with water, it's going to carry the velocity potential of the Earth with it, and that's going to, you're going to be able to measure a deviation angle. So that's that's the logic behind what this lad was doing here with the crystal prism. He was trying to establish that velocity component based off of a timing difference due to a medium change. All right, I'm going to get some water real quick. All right, so prior to Airy, there was a guy named Professor Klinkerfues. He was a prestigious German physicist and astronomer in the 1800s as well, 1856. He laid out an experiment in which he claimed to have measured the angle change that would substantiate Earth's orbital velocity. So earlier we were talking about how Arago with the crystal prism predicted a specific angle based off of that change. Well, this dude's saying that he did that and he measured the angle change. So we're going to get into the rationale and what he used to derive all that. So this is the aberration of the fixed stars. Someone's hot micing. This is under the term of aberration. Two processes are almost always combined in the writings in dealing with this subject. First, the delusion, which are the subjects by the direction of a ray owing to the motion of our point of view, which is quite comparable, is that which we fall in the fast moving carriage or railroad over the direction in pouring rain. Secondly, the real change in the direction of a ray, which also caused by the movement of the earth as well. The former may be called a psychological, and the latter part is called the physical aberration part, due to, the mechanism of the earth being in motion. So he's stating here that there's an apparent effect that can be perceived, and there's also a dynamic effect, a physical effect that's caused by motion, not to be confused with an apparent effect. So earlier when we were talking about James Bradley and stellar aberration and the deviation, and how that's just a measurement, and that can't tell us if the effect is, apparent or if it's physical. We would have to manipulate the independent variables in there. You'd have to introduce a medium per se to start to change the dependent variable, which is the measured angle. So this is the baseline of what he's suggesting. So some people will say that this experiment, that Airy didn't do this to confirm the Earth's orbital velocity. We already knew Earth's orbital velocity. And then you ask them what experiments proved Earth's orbital velocity prior to stellar aberration, and they'll literally say stellar aberration and parallax. But as we just covered, those are kinematics. Those are measurements. They can't tell you which is in motion. The purpose of this was to introduce a dynamic asymmetry to the system where you can determine which is moving. So confounding these two different effects under the concepts of aberration, by aberration being understood to mean the total and apparent change in a real direction of a ray caused by Earth's motion, has nothing less than been favorable to the treatment of the object. So we're talking real effect versus apparent effect, and how we're going to manipulate an independent variable to change the dependent variable. We're going to change the speed of light in that equation to see if we get an angle increase. So this remark is, and some people will say that this experiment had to do, with the ether, and there's no ether drag, and that the ether wasn't present. So the water didn't know to carry the 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 light in the opposite direction or whatever. None of that stuff is relevant. This is all based off of classic principles. None of it has to, there's no ether variable in here. What we're going to be looking at is the law of cosines and Snell's law to derive these predictions. And so anyway, we'll continue on to see what Klinkerfues has to say. This remark, essentially pronounced by Fresnel, in other words, thus gives a property very important to the theory of aberration, in which the physical aberration is altered when the deflection of the ray by the refraction or reflection, or what appears to be quite the same influence of the Earth's motion on the refraction and reflection. Since we obtain by this way of experience independently any hypothesis about the transitory motion of the flow or ether, we have the same time gained experience of the latter. So what he's saying here is that it doesn't matter if there's an ether or not, or like if you conceptualize it as being in motion or being stationary. The effect of what Fresnel measured is that a medium carries a velocity component to it, and you should be able to measure that independently of any ether effects regarding the flow or static nature of it, and that's going to give you an angle change. So on the basis of the proposition, according to refraction and reflection are explained in the wave theory, it follows that the influence of Earth's motion on the reflection and refraction is just as it should be when the ether, both of the medium of the world of space, would be quite free from the transitory motion, or rather as if merely a partition of the refracting media were moved without being accompanied by the transitory movement of the ether. We conclude that either the ether is really at rest, or that its translational motion has no effect whatsoever on the appearance. This dilemma, we find the former assumption reprehensible for various reasons, so we decide according to the experience for the second, but we are able to prove the latter, that is, independent of the physical aberration hypothesis about the transitory motion of the ether. It is in harmony and within the fundamental doctrines of wave theory, but we refrain from doing so. Note that the independence extends only to those phenomenon which are the present one, have to do with the position of plane waves and their normals. The diffraction phenomenon in this example, which other conditions are still decisive, one cannot assert independence from the phenomenon of the transitory motion of the ether. It is known that Fizeau's acumen in diffraction phenomenon has been recognized by means of measuring the transitory motion of the ether itself in certain hypothesis of Fresnel, which we will cite later. And what he was talking about there is that even though for this derivation I'm going to do here in hypothesis, I'm not saying that there's no ether effects, right? We know that our boy Fresnel had his hypothesis experimentally confirmed by Fizeau. So there may be some effects, and we'll consider those, but these effects should be independent of anything like that. Then he goes on to get into his derivation. He starts with a sine and Snell's law, and basically when you reduce it all down, it comes down to the equation that we were looking at earlier, which is just the angle change in the velocity of light over the velocity of Earth over the velocity of light to predict the angle change. And for the medium that Klinkerfues was using, he was using turpentine oil, and he said that he measured the angle necessary if the Earth were in motion. And so Airy was like, hey, I'm going to have to go and confirm that. But before we get to Airy here, I just thought this was really funny. This is Fresnel writing to Arago. So Fresnel is writing to Arago, who earlier did the experiment with the crystal prism and found that it's the same as if the prism is at rest. And the way that he words this is just really funny. He says, by your beautiful experiments on the light of the stars, you have shown that the movement of the terrestrial globe has no appreciable influence on the refraction of the rays emanating from these stars. That is a very generous interpretation, because the direct implication is that the Earth is stationary and the stars already come in at an angle. You have to like literally disregard that fact to to even say this, because what they had to end up saying later when Airy did his experiment was that somehow there was ether in the telescope bouncing around carrying the light in the opposite direction. Pretty preposterous. All right, so we're going to look at Klinkerfues' apparatus here. So this is what Klinkerfues was rolling with. Very nice. This was in 1853, something like that. Now, to give a quick recap on the situation at hand before we get to Airy, we're going to look at a summary of experiments done to test the motion of the Earth back in 1898. The summary is given by Wilhelm Wien, who says experiments with a positive result. And the list given here is number 1. So we have the aberration of light of the fixed stars. The aberration found in the simple explanation of the basis of the emission hypothesis, which it turns out there was a major oversight there that we'll get into at the end. And the difficulties of the undulation theory are only recently eliminated by Lorentz by assuming ethers. Okay, so we have, and this is this is doing a transformation to change velocity vectors, which we'll get into why that doesn't work. So there's actually no explanation given, but anyway, this is just in the context of how they were trying to reinterpret it as a proof of their model. So the positive measurement of aberration in just air. And he says, this is of great kinematic significance, but nevertheless, it must be taken into account of the question of resting or moving ethers. Because if the Earth is stationary and the light already comes in at that angle, you could argue that there's a medium that's in motion in between the starlight and you that's causing the light to come in at that angle already. So you always see that apparent position. But anyway, he goes on to say, the experiments that give negative results an attempt to see whether the movement of Earth influences the refraction of the incoming light from a fixed star, which is Arago and Airy. And then he goes on, and in this list, he goes on to list Michelson-Morley from 1887 and about 9 other ones, but the other ones aren't really relevant. But basically, history of no confirmation of Earth's motion when you try to manipulate independent variables. We only have a measurement with a ratio that gives a good agreement, but no actual experiments. So, all right. And the experiment is like mislabeled here for stellar aberration because there's no manipulation going on there. So this is just an observation. But anyway, when they go to manipulate the independent variables to change the dependent variable, which is the angle that's deviated from their assumed true position, they get no actual difference. Okay, so now we're ready to get to Airy now that we've learned the full extended history and all that. And actually, before we move on to Airy, I'm going to get everyone has to take a pop quiz and prove that they understand everything now before we can move on.
Yep.
I'm just kidding. All right.
Oh, I was going to ask you a quick question. You said before,
Absolutely.
like ether, no difference. That doesn't make a difference if there was or wasn't ether in the measurements.
Mm-hmm.
Okay.
Yeah. There's no ether variable in there, so there's not like, oh, we have to account for the ether density or something. You know what I mean? Like, there's nothing like that in there. It's literally just the refractive index and angles and cosine. And the corresponding cosines.
Yeah.
All right. So Airy. So now we're going to look at Airy's experiment and his apparatus. So he used a Zenith mounted telescope that was completely filled with water. What we're looking at is a side view of the diagram here. This is a spindle that's completely fixed. They have 2 spirit levels to make sure that this is perfectly level. So people that say level means curved and all that stuff, well, it was level enough for them to determine that heliocentrism is true or whatever. So turns out you can use spirit levels to determine actual level. And so they got their level telescope. They got a attached to a spindle where they can make an observation and then they could rotate it 180 degrees and make the same observation and cross-reference it for accuracy to make sure that it's accurate. And we'll scroll down and get into the technical specs of it here. So it was 35 inches. It was completely filled with water up to the top. They had some problems with air bubbles or whatever. So there's a little thing that you can insert a straw to suck out the air to make sure that it's completely filled. So so it's always, at a perfectly straight and level. And then they had thermometers on the sides of it at the top and the bottom of the telescope, so they could take measurements of the temperature of the water difference, to make sure that the difference there wasn't causing any additional effects, things like that. But more importantly, what we're going to be looking at is the micrometer and how they make the adjustments, the fine adjustments to the positioning of the telescope. So this is from Aries' paper here, and we're going to read what he says. So he says, in 1867, attention was called by Professor Klinkerfues of some German university, place, to an investigation of the passage of a light ray on the undulatory theory through a definite thickness of a refracting medium, and said that the effect would be produced on the apparent value of the coefficient due to sidereal aberration, meaning that there would be an angle change corresponding to 30 kilometers a second to facilitate, that would give a proof of Earth's motion. And Aries was like, well, Klinkerfues is a big deal. He's a man of repute. So I'm going to confirm his experiment here. And he's talking about how he did it with his telescope filled with turpentine and did the transits of the stars and found the respective minimum and maximum values. So in other words, when you're moving towards the star and moving away from it, when the Earth is perihelion and aphelion, you would have to tilt it back and forth. And he's saying that he had to do that to the tune of I think it was 7 arc seconds it came out to, or something like that. So Airy was like, okay, dude, I'm gonna have to test this out, boys. Get the lads together. I need a spindle that can be adjusted with micrometers, with micrometer screws. So what that means is basically 1/1,000,000th of a meter. So they have a screw thread that's 1/1,000,000th of a meter, and they have wire threads that are 1/1,000,000th of a meter that they're going to use to make a grid that they're going to put on the optical piece of the telescope, so that they have a grid to look at these stars, and then they're going to use that grid to represent distances in arc seconds relative to a celestial sphere. So that's how they determine the distances and deviations and all that. So here's a diagram of the apparatus here, and this is at with the telescope at 180 degrees while we're looking at the apparatus from the east. And there's a bunch of technical specs here. I'll actually link this in the chat. You guys can check it out. I'm not going to go through all the tech specs because some of it's kind of like not important. But if you're interested in seeing them all, I have them all laid out in bullet points. So here's a link to that in the chat. But yeah, I already went over pretty much the most important parts. So we're just going to look at the diagrams here. So here's a top-down view of that spindle and how you can position it 180 degrees from its original position where you take your first measurement. Here's the telescope alone with the going down into the eyepiece. So this is completely filled with water all the way to the top. There's I think it's not actually shown here, but there's a slit here where you can put in a straw to suck out the air. Then here's another top-down view of that. Actually, no, I'm sorry. This is for the micrometer and the eyepiece. And then here is the micrometer. And here's the grid that they're using. So these are micrometer threads that are overlaid in a grid. So there's 25 of these in either direction that form this cross-section grid. And what they'll do is they'll take the telescope, they'll adjust it around this spindle, so they can rotate it 180 degrees, but they'll get it positioned under a star, and where the zenith should be at 90 degrees, and they'll look at the position of the star in this grid, and they'll take angular size measurements of it, because they've got it broken down into little sections here. And then once they know the position and the deviation from where they expect it to be in the center of this grid, they rotate it 180 degrees, take the exact same thing, and make sure that they are accurate in their measurement. And they count how far away each one of these diamond sections are that intersect here. That corresponds to arc seconds. So that's where they're getting these measurements. That's the conversion. That's how it works. It's like, that's extremely important, because when I first heard of this experiment, I always contextualized it like, they were looking through a crosshair, it wasn't like this level of precision or insanity, but this is like, really, really precise and elaborate here how they came up with this system. So very cool. Shout out to the boys. Very intuitive. And this is just the micrometer here again. And then here we have the micrometer threaded screws that allow you to basically, you can determining the position of the telescope and how much you had to rotate it would be. And keep in mind, this just rotates around a vertical axis. So it doesn't tilt like vertically. It moves horizontally around a vertical axis. It doesn't tilt vertically. So this is it's always straight up at 90 degrees, but they can adjust, they can move it around the spindle. And anyway, the adjustments that they make, they can correspond the rotation of one of these threads of the screw to an arc second. So all of these measurements are bound to the sky. All right, then here's more diagram stuff, just an overlay of all that, but we already went through all that. So you guys can check out the extended tech specs if you're interested in it. But now we're going to skip ahead to some summaries, and then we're going to get into the modern explanations and refutations to Airy's failure that try to rectify the experimental measurement with the hypothesis that the Earth is in motion. So, quick overview from Airy's paper here. He says, I can bring this up bigger. 1 second. There we go. All right, cool. That might be a little easier to read. Okay. So the hypothesis was the Earth is moving at 30 kilometers a second. Klinkerfues said that when he introduced a medium to his telescope, he had to compensate for an additional angle correction that corresponded to the increase that would be due to the velocity of Earth. Airy said, okay, bet, I'm going to test that. He puts water in his telescope, does his measurements, and what we're looking at here is a summation of the first 6 months. And there was only a 0.8 arc second difference. The expected difference was 30 arc seconds in total, 15 arc seconds for the first 6 months of the year. And then they would have to go back 15 arc seconds for the latter part when you're perihelion and aphelion. So what he says here in conclusion is that I think myself justified in concluding that the hypothesis of Professor Klinkerfues is untenable. And the hypothesis, remember, that we just went over, was that when you introduce a medium, there's going to be an angle change due to the velocity of Earth because you're manipulating the velocity of light, and that's going to allow the Earth to move further, and that's going to increase the angle. That was the hypothesis. Had it been retained, the aberration to be employed and the corrections would have been increased by plus 15 arc seconds and minus 15 arc seconds, respectively, and the two mean of the results would have disagreed by 30 arc seconds. So, in other words, again, we have a situation where the refractive index is this of the supposed moving medium is the same as the absolute fixed medium. So whether or not Aries said, hey, by the way, this means that the Earth is stationary, that doesn't have to be included. This is an obvious logical implication, and we'll further get into that as we continue. Now, 1 second, I got to bring the Prezi back. All right. All right, so that's the logical implication there, that the Earth is stationary and the starlight already comes in at that angle. So I'll read a little excerpt here from Robert Sungenis and Robert Bennett's book, Galileo Was Wrong, The Church Was Right, published in 2007. Science claims to be logical and rational, while religion is not. The following syllogism demonstrates what Aries' experiment logically concludes. A. If the Earth moves, the water in the telescope will need additional tilting. B. But the water in the telescope does not need tilting. The effect would be false in this case. C. Thus the Earth does not move, so the cause is false. So if you assume that the cause of the need to tilt a telescope is Earth's motion, and you don't have to tilt the telescope, there's no effect, and therefore there's no cause. So there's no reason to do it because you're not moving. This is valid logic. If the effect is not present, neither can the cause be present. For if the cause were present, so would the effect. But supporting the geocentric model is unacceptable to the prevailing modern ideology. In fact, the experiment was called Aries failure because it contradicted the heliocentric metaphysics. The term Aries failure gives the psychological insight to the thought of the experimenters during the era. Earth's motion with respect to the ether was universally accepted as the only outcome. Both this experiment and Michelson-Morley experiment were thought to be dead ends in understanding reality until Einstein rescued the theory by ignoring the evidence for geocentrism and ether and opting instead for special relativity, which gave a mathematical solution at the expense of logic. Well said. Shout out to the lads who wrote that. Some really smart dudes. All right, so we're going to read a little excerpt here from Michelson-Morley, 1887, who gives a quick recap on the situation regarding the implication of the telescope and the aberration angle in Earth's motion. So on the relative motion of the Earth and the luminiferous ether. 1887. The discovery of aberration of light was soon followed by explanation according to emission theory. The effect attributed to a simple composition of the velocity of light with the velocity of Earth in its orbit. The difficulties in this apparently sufficient explanation were overlooked until after an explanation on the undulatory theory of light was proposed. This new explanation was at first almost as simple as the former, but it failed to account for the fact proved by experiment that the aberration was unchanged when observations were made with a telescope filled with water. For if the tangent of the angle of the aberration is the ratio of the velocity of the Earth to the velocity of light, since the latter velocity in water is 3/4 its velocity in a vacuum, the aberration observed in water with a telescope should be 4/3 its true value. And then he gives little asterisks here for us to read some additional notes. And it says, it may be noticed that most writers admit the sufficiency of the explanation according to emission theory, while the fact that the difficulty is greater than according to the undulatory theory. For the emission theory, the velocity of light must be greater in the telescope, and therefore the angle of aberration should be less. Hence, in order to reduce it to its true value, we must make the absurd hypothesis that the motion of the water in the telescope carries the ray of light in the opposite direction. So he's saying if you think the light is a ballistic particle, that you have to say that in order for there to be no angle change due to the velocity of Earth, you have to say that somehow the photon, or whatever you're conceptualizing the light packet as, has to travel faster in the medium, so that the distance changed by Earth's velocity doesn't cause an angle change, which is preposterous. It's a violation of the conservation laws. Where would you get the extra energy? Where did it go? What happens when it comes out of the light or what comes out of the water, etc., right? Nobody would actually take that position. But it's even worse for the undulatory theory, who the explanations put forward by Fresnel and Stokes was that there is a static ether, but somehow in the telescope, the static ether becomes mobile and it's bouncing around in the telescope and it's carrying the light in the opposite direction of motion such that it cancels out the additional angle that would be produced due to the Earth moving out from underneath the starlight. Or you could do a Lorentz transformation and basically assume Earth has a velocity component to it, and then you transform that velocity component to the incoming light, and that cancels out the angle change, because now the velocity of light and the incoming light has the same velocity vector. So now they're going to, now it's not going to have a deviation. But the problem with that is when you do a Lorentz transformation and you treat the Earth as stationary, you can't have a velocity component anymore. And that conflicts with relativistic velocity composition, which we'll get into, which gives the accurate angle prediction that is, that's actually identical to the classic prediction down to 2/10,000,000ths of an arc second. So relativity, when properly applied without an asymmetric use that violates Lorentz symmetry and basically shows that you're forcing an agreement by assuming a velocity, you can show that the Earth is stationary. So like obviously those positions are preposterous, because, we're dealing with a first order measurement. We're dealing with a measurement in the lab frame. You're not going to transform to the frame of a incoming light wave or photon packet. That's ridiculous, right? That's assuming the velocity vector to be there. That's not, you would have to have somebody in the light wave frame confirm the inverse, right? No one's in the light frame doing the experiment. All we have is the lab frame. So that framework to explain it is completely preposterous. So anyway, we'll read at the end here. Go ahead.
Is it possible? Can you just dumb that down a bit? Because
yeah, absolutely. No worries. Absolutely. As we continue on here, I'm actually going to show what I'm talking about in the equations to break all that down. But we're getting to that point as it's coming to a head. So I'm just kind of laying it out. But yeah, absolutely will do. Okay, so we have the end of Michelson-Morley, the paper here, before it gets to the supplement. This is at the conclusion. So they're saying that the velocity that they measured was much slower than expected, blah, blah, blah. But the important part in relevance to the proposed ether theories that could potentially explain this measurement are not valid, because this measurement exceeds the values that would be required to make this experiment like a null result, because they actually measured 6 kilometers a second. And they could only use the theories of Fresnel and Stokes and Lorentz if the measurement was 2 kilometers a second, because that would be within their error margin for plus or minus for air tolerance. And they could chalk it up to experimental error and say, you know, the speed of light's actually constant in all directions. But what he goes on to say is that you can't use that here. You can't use Stokes and Fresnel's theory of the ether canceling out, because we did get a measurement that exceeds that. And also Lorentz's is incompatible. So that velocity component transformation that I mentioned earlier, where you would be able to transform and predict a null result, is incompatible because they actually measured 6 kilometers, and that's too big. They're supposed to measure either 30 or nothing. Because if they get nothing, they could mathematically obfuscate it. If they get something that's, you know, significantly less but more than their error bar, like they can't mathematically ignore that. So what they ended up doing was just, you know, was just rounding down their 6 kilometers a second to 0, so that they could do a Lorentz transformation, which is identical to the framework of special relativity. They're mathematically identical. So they did end up going with the Lorentz's explanation, which is, you know, through those transformations. But anyway, now we're going to get into some of the specifics of that. And like I said, we'll go over the math to show the equations of what I was just talking about with the velocity composition and all that stuff. So we have a textbook here from Wolfgang Pauli from 1958 on relativity. And he's talking about his interpretation of he's talking about the relativistic interpretation of Airy's failure and how it's very simple. So basically his explanation is, if you take the reference frame of the water-filled telescope and you take the reference frame of the Earth, both of these are stationary, and there's no relative motion between them. Therefore, he should predict no relative motion to be measured for the incoming light of the starlight. And that's obviously absurd, because the measurement is made with respect to the star as the source emitter, and the observer is, you know, the telescope. So you can't use an analysis of relative motion between the telescope and the lab frame if your baseline assumption is that the lab frame is in motion. That's, you know, like, that's so, you know, anyway, that's like absurd, right? It makes no sense. And he goes on to say that, like, that's the easy way to explain it. What Lorentz did was very complicated and unnecessary. And keep in mind, what Lorentz did, that transformation, his framework, is identical to special relativity. There's no difference. So the actual explanation, you know, is, I don't know, I just thought that was crazy that he thought that was a valid explanation, because what'll often happen is a relativist will invoke a frame that has nothing to do with reality, and they'll try and make the experiment in that frame. And it's like, no, we have a measurement done on Earth in the lab. We only have the lab frame experimental confirmation. We don't have another frame to analyze this from.
So you're saying the counter argument to Airy's failure is this Lorentz thingamabobby?
Yep, that is one of them. And I'll show you a Lorentz transformation here in a second. All right. So when you get into the classical explanation for how to predict the angle, what we went over, where it's just sine, cosine, tangent, the velocities, and then the ratio of V over C gives you your angle. So velocity of Earth would be 30 kilometers a second. Velocity of light would be, it's like 300 million kilometers a second. So there's where our ratio for the angle comes from. So the deviation from the 90 degrees would be produced by this. And when they say, okay, well, you have to do relativistic velocity addition because you were dealing with the speed of light. And when you're dealing with the speed of light, you know, relativity must be blah, 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 right? So they have their own way to do this derivation where they have this little factor here. You'll notice these equations are pretty much identical. right? And the velocity components in the axis. So the X and Y axis would be your direction axis, your direction of motion for your X. Your Y would be your incoming light. So like the vertical axis. And then we have these gamma components here. This is what's called link contraction and time dilation. So what's been added to this now that makes it quote unquote relativistic is we've introduced the gamma factor. We've introduced gamma, which is link contraction and time dilation. And this is a change in the x-axis and the time axis as a function of velocity squared over c squared. Let me pull up a proper Lorentz transform for us real quick so we can see what that looks like. So a normal transformation would look like, okay, we're going to change, we're going to do position, we're going to do a change in position over time. So we're going to, this x-axis, the new coordinate, the x prime is going to be equal to the original x-axis minus the velocity times time. And that's going to give us the new position. And then everything else is going to be equivalent position. So we're just looking at a change in the x-axis. So that's how you do like a regular Galilean transformation. Now, when you do a Lorentz transformation, we're looking at a change in not only the x-axis, the direction axis, but also the time axis. Those two are going to change as a function of velocity squared over c squared. So it's going to change by a really, 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 really small amount. And if you're not moving, if you're not dealing with velocities that are at relativistic speeds, meaning like, you know, like 10% of the speed of light, the effects you are going to get out of this are going to be extremely small. So when you're considering 30 kilometers a second over 300 million kilometers a second, I mean, you know, it's extremely small. And then now we're going to square that. So it's going to be even smaller. So this is what the Lorentz transformation looks like. So when they add that gamma factor here, this B, this beta, this is the gamma factor. This is just how it was written originally or whatever. So these are equivalent. When you see this beta or when you see the little gamma symbol, those are talking about the same thing. So we're going to change the coordinates by the gamma factor. Now, but because these velocities are so small, what's actually going to happen is this gamma factor is negligible. It's going to cancel out and make no noticeable difference. But the classical part of the equation, which is identical to the actual classical equation, is going to produce the actual angle. And the small term from the gamma is going to be neglected. So doing quote unquote relativistic velocity addition via Lorentz transformation and introducing gamma factors and whatnot doesn't change anything, because when you math this out, the ratio, the difference between the classical prediction and the relativistic prediction is 2/10 of an arc second. So they both agree that the angle from when you make the measurement in air for stellar aberration, it gives a 20 arc second angle. And when you add water, the classic theory of how it should be derived based off of, you know, just velocity for the aberration being a ratio of the velocity over the velocity of light, and Snell's law for the refractive index for the slowing of the water predicts that there will be a 27 arc second angle. And when you do the relativistic velocity composition, which we just went over, where we're adding this extremely small negligible term that cancels out, we get a number that agrees all the way down to 2/10 of an arc second. So there's no difference between the classical prediction of how much the angle has to change if the Earth is in motion and the relativistic one. Okay. So that's extremely important, because when you get into modern interpretations that are going to be put forward to refute this, they're ignoring the velocity composition that actually predicts the angle. And they're going to do a transformation that adds a horizontal velocity component to the incoming light that's going to make it match. And so they're actually going to say that they predict no change, which is crazy because you can't predict 27 arc seconds and be in agreement with the classic theory and also predict 0. That doesn't make any sense, right? So now we're going to, if anyone has any questions real quick before we move on, I hope I covered that velocity addition and relativity stuff sufficiently there, or to give you like a baseline to get into it. So if there's any questions or anything further, we can take a quick break before we get into the videos. All right, awesome. I'll take your silence as acquiescence. Oh, okay. What's up?
Just to recap, I guess.
Yep. No, you're good. You're good.
I have a question, but it's a silly one, so I'll hold it till after the presentation.
All right. Well, let our boy go with his legit question.
I am just like trying to dumb this down for myself. So.
Yep.
So yeah, basically it was like Aries failure and the Lorentz thing was a counter argument. Is that what you're saying? The gist of it?
Yeah. So because they made a measurement that absolutely can only be interpreted as the Earth is stationary and the light already comes in at an angle, they have to do a mathematical coordinate system transformation where they first assume they keep the assumption that the Earth is in motion on the x-axis of the coordinates, right? So like horizontally, you can think of it that way, relative to a vertical component. So on a horizontal axis, they're taking that velocity that they're assuming of 30 kilometers a second, and they're moving it to a new reference frame, and that new reference frame is the incoming wave. And so now the wave has a velocity component to it, and that's going to make it already come in at an angle. So if they can do that to get the light to come in at an angle, they would predict that when you add water, there's no angle change. So that's what they're doing there. They're like, it's like a mathematical reification, and that's not even valid because they're supposed to be treating, in that transformation, you have to treat one of the frames as stationary, because in the analysis, remember the stars are, so far away, they're fixed or whatever, right? So you got your fixed star in that frame, and then we're in motion. So now we're going to do a Lorentz transformation. So for symmetry, we have to make these frames equivalent. So the Earth has to be treated as stationary. It can no longer have a velocity component. So it has to be treated as stationary. And then you could give that velocity component to the incoming light. And if you do that and you treat the Earth as stationary, then you actually make the correct prediction that there will be an increase in the angle.
So what are you saying? Like the light coming from the star is not coming straight down from the star, it's coming from an angle from the star? Or is that
Yes.
getting that correct?
Yes, it's coming in at an angle. And the way that their analysis is working, though, for them to give an explanation, they're subtracting Earth's velocity and giving it to the incoming light, but also dynamically, like in reality, the Earth is still moving in their model. So they can't make that match. It doesn't actually give agreement. To make it actually symmetrical in the transformation, you would still have to predict an angle change.
I think I kind of get it. Yeah. Like
So there's
light from the star is coming in from an angle.
Yep.
So if you do this prediction and just use the Earth is stationary and the star is moving, it works right. But if you try to use the globe thing, you have to do some crazy Lorentz contraction thing and all that.
Well, yeah, not contraction. Yeah, you have to do what's called vector velocity vector summation. So you have to, so you got this x-axis velocity component and no y-axis motion, right? Because it's from the Earth perspective, right? And you're just assuming the Earth's in motion, and then you have this incoming photon that has a vertical velocity but no horizontal velocity. So you're going to flip-flop those two for the transformation. So you're going to impose one on the other and vice versa. And when you do that, you would predict that there is an angle change, because what you're doing is you're showing like you're showing the reciprocation between the two frames, and that gives actual agreement with the relativistic velocity addition for what we went over earlier, for how they would for the prediction for the angle change when you introduce the gamma factor and all that. So like they do actually predict an angle, but the only way to get out of the angle prediction is to do a invalid transformation and apply the light velocity to the light asymmetrically, and then interpret that as if your experiment matches expectation. But they're forgetting that the Earth has to be stationary in their analysis. They can't do that. It has their transformation also has to produce an angle change, because the angle change is what's measured in the lab, or what would be predicted. So, all right. So now we'll get into some refutation. So Austin recently did a debate on Tim Pool's podcast with Astronomy Live, and an explanation was put forward by Astronomy Live that this experiment was about an ether, and there was no ether to carry a lateral velocity component, and the water didn't know that it had to slow down the light in the horizontal, like just all this ridiculous stuff. So I'll let him lay it out, and then we'll go over the refutations at the end here. So this is Astronomy Live. I'll let him.
Stellar aberration.
See, we're going to play it at 1.5 speed as well to kind of save on time.
Is a phenomenon where starlight will enter the telescope at a slightly different angle depending on what time of year it is, due to Earth's orbital motion around the Sun. For the purposes of this illustration, I'll exaggerate the angles involved, but in reality, the shift is only about 0.006 degrees at most. But now with stellar aberration included in the simulation, you can see that the photons of starlight are entering the telescope. Now let's make the telescope tube transparent so that we can see the photon of light traveling down the tube to the back end. Now, of course, in this example, the telescope is simply filled with air, which has a minimal impact on the velocity of light. But in 1871, astronomer George Airy tested the hypothesis that if you filled a telescope with water, which would slow the light down, that you would see an increased amount of stellar aberration due to Earth's orbital motion as the photon passed through the water in the telescope. In the 19th century, it was thought that light was traveling through a medium known as the luminiferous ether, and as Earth orbited the Sun over the course of the year, you see a shift in the star's position due to stellar aberration because the light is entrained in this medium that has a velocity vector relative to Earth that is changing due to our orbit around the Sun. This led to the hypothesis that if you slowed light down by using water or some other dense medium to reduce its velocity through the telescope, that you would see a greater amount of stellar aberration because it was thought that light was entrained in this ether, and so it would not affect the lateral motion caused by Earth's motion relative to the background ether. If we look at these velocity vectors of this photon as it approaches a water-filled telescope, it was believed that the water would slow the light down along the green axis through the telescope, but not the red line representing the amount of stellar aberration caused by light being entrained in the luminiferous ether. It's important to note that a lot of space deniers today will make this assumption implicitly. Whether they explicitly state that they believe in ether or not, they will want the viewer to believe that water should only slow the light along the long axis of the telescope, but have no impact on the lateral velocity of light relative to the telescope caused by Earth's motion.
No, it's actually not our position at all. That's his position. He's arguing that the light isn't slowed down in a certain vector, right? In that horizontal velocity component. We're arguing that the light is slowed down in all directions. It doesn't matter the vector, right? It's slowed down in all directions, which is going to cause the angle change. This is just like absurd reasoning and argumentation that's put forward.
Of course, this begs the question, how would water know to only slow the light along the long axis of the telescope, and why would it do that? If the answer is that the photon is entrained in the luminiferous ether, and therefore the lateral motion is still there regardless of the light slowing it along the long axis of the telescope, this needs to be stated explicitly, and evidence for this luminiferous ether needs to be provided.
And again, just to recap, as noted by Klinkerfues, none of this has to do with an ether mechanic as an actual mechanism. This was all derived from cosines and Snell's law, the refractive index. And so it's very simple. If the light slows down in water, then the Earth gets to move further. And if it moves further, the angle is going to increase. If the water is put in the telescope and the angle doesn't increase, then the Earth isn't moving.
In this illustration of a water-filled telescope, the photon slows down once it enters the telescope's water-filled tube, but the angle which it exits the telescope is the same as the angle with which it entered the telescope. This is what Airy observed. The water in the telescope had no impact on the angle of stellar aberration. The water had no way of knowing that part of the angle that the photon entered the telescope at was due to Earth's orbital motion, and to leave that relative motion alone as it slowed the photon down.
What does that even mean? Like, just hearing it again is hilarious.
This is what it would look like if the photon was entrained in
the position and then calling it fallacious.
It's the only way to deal with this, as we're going to continue to see.
Ether that would continue to drag the photon even as the water slows its progress down through the telescope. Entrained in ether is just a way of saying that the photon is embedded in the medium, and therefore it will be essentially dragged through the water by Earth's orbital velocity relative to that medium, regardless of the water slowing down the progress of the photon through the telescope. Of course, this is not the result that we see in reality, but this result is only predicted if the photon is embedded in a medium that maintains that lateral velocity regardless of the slowing effect of water.
Nope. It's dependent on the timing difference introduced by the medium in the physical movement of Earth out from under it. Has nothing to do with lateral velocity components of ether being entrained and talking to the water and telling it like, yo, bro, you got to slow it down on the horizontal axis. That's absurd.
Until next time, thanks for watching. And
so yeah, what he ended up concluding is that the angle, when you put the water in, it doesn't change anything. So welcome to a stationary Earth. Very cool. And then there was some comments in his YouTube section where this guy was like, hey man, this doesn't make any sense. So are you saying that the speed of light in water does or doesn't change? Can you help for some clarification? He goes on to say some nonsense about how there's no way of knowing, blah, 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 lateral velocity component. And then some other guy chimes in and starts saying that it does change, but it doesn't change. And then the reference frame of the water, blah, blah, blah. All this absurdity, right? And what we went over earlier was that woman measuring using a laser meter, the timing difference in the speed of light in water. So whether or not you want to conceptualize it as a constant speed, but it's going through the molecular structure, interacting with electrons that are re-emitting the photons, and then those are going in a different direction through the path length of the molecular structure of the water, et cetera, doesn't matter. All leads to a timing difference, which is the pivotal piece of information here that is being ignored. And when you ignore that, like, that's when you start coming up with these gaslight explanations to try and explain everything. So anyway, this dude gets gaslit to infinity, and then he ends up saying, thanks for the explanation. I really appreciate it, and I understand it more clearly now. And that's really sad because that guy didn't say anything coherent that made any fucking sense. So my buddy Toby always says, never gaslight your own soul. I think that's extremely important. You should always follow that advice. Never gaslight your own soul.
Rest in peace, the Caker Edox.
Yeah, dude. Rest in peace to your boy. So the hypothesis proposed that light slows down in a denser medium should increase the angle change. So before I found that video of Looking Glass doing her experiment with the laser meter, I had a practical example. Like, if you don't think the light slows down in water, then you would predict that there's no displacement in this dude as he's in a pool there. You would predict that you should see him just, exactly the same. But then I found that awesome laser meter thing, which is way better. So that's a better way to definitively show it. But anyway, the baseline of modern astronomy was measured by Fizeau, Foucault, and I think another lad who I can't remember. But anyway, they had an interferometer where they could introduce air at different temperatures and different levels of like humidity and density or whatever. So they were testing like refractive indexes to see what the timing difference would be on the speed of light, to see how that would affect their observations through a telescope. And what they found was that it didn't make that much of a difference when you're doing air. But there was a timing difference that was measured, and that this is the like, you know, to say that light in a medium doesn't change speed is, you know, preposterous. It's literally the backbone of astronomy. All right. All right, so I'll just read this. So somehow Arago must have heard of the news, because 2 days later, on April 29th, he gave a strange speech at the Académie, lining out the history of the measurements for the relative speed of light in air and water. He reminded those present of the original experiments many years before with Fresnel in those first interferometric measurements of the refractive indexes of dry and moist air, but how had this contained the ambiguity on the relative speeds of motivating him for a direct experimental test? So again, this was just him commenting on, you know, the variance measured there for the timing difference. And then of course we have the Fresnel drag coefficient, which is what was measured with the water inside of the interferometer, the running water that goes in a rectangle that we talked about earlier. So the classical prediction and the relativistic prediction are identical, and Fresnel derived his velocity addition prediction in 1818. So way predates relativity and any transformations or anything like that. And it's interesting too, because he notes that the density of the elastic ether in matter is proportional to the refractive index squared. So that's a really cool excerpt there. But anyway, this is taken from a textbook from, can't remember the dude's name, but anyway, just more showing that the classical theory, you know, makes the correct prediction every time, but introducing quote unquote relativity isn't changing anything. It's not making it better. And the only thing that they've done substantially with it when introducing it to the classic equations is just doing a transformation where they're imposing an assumed velocity vector on a frame that no one can do a measurement in to confirm it, which is crazy. And then another example of the speed of light being measured differently in a medium, especially a moving medium, is Fresnel drag is incorporated in inertial navigation systems. So in ring laser gyroscopes, the tubes are filled with a gas. Sometimes it's a mixture of helium and some other stuff. But anyway, when they ionize that gas, it creates a preferred direction of flow from the electric current that's doing the ionization. And the movement of the gas through that tube is adding velocity to light that has to be compensated for and canceled out so that it doesn't interfere with the readings and give inaccurate results. So they put anodes, and they put additional anodes and cathodes inside of the tube chambers that emit an electric current that is proportional to what's needed to cancel out the preferred direction caused by the current that's causing the ionization for the laser. So that's a really interesting and intricate effect that happens even on this really small, precise scale, because you wouldn't think that something like the movement of electricity causing a preferred direction in a gas is going to affect the speed of light that much to where they need to compensate for it to make a precise measurement, but yet they do. So this is just more the speed of light being measured at different velocities in a medium. So it can be slower, it can be faster, and it depends on the motion of the medium as well. And that was experimentally substantiated by Fizeau in 1853, and that was proposed by Fresnel in 1818, and it's still used today in modern ring laser gyros. And this is just from the manual from a gyro explaining what I just laid out about how the ionization creates a preferred direction and how they counteract that. And then, of course, we have your girl measuring the timing difference with a laser meter. And then we have the arguments that are the assumption relied on the idea that light is entrained in an ether, meaning that it was influenced by the motion. And then also we have in Aries' experiment, the water-filled telescope slowed the light down, but it did not change the aberration angle. This contradicted the idea that light was entrained in ether since no additional aberration was observed. And as we just went over, that's a complete straw man of the position. This is a physical, like whether or not you believe in an ether, this physical effect has to occur because it's due to the Earth physically moving out from underneath the starlight, which is said to be the cause in air. Because here's the thing with the Lorentz transformation, right? If you assume a velocity vector for the incoming light and you're transposing that into the light, when you make the observation in air, you predict that there's no aberration because the light is already coming in at that angle that's matching your velocity. So now you don't even have aberration to begin with. You would predict no aberration. So when you fill this with water and do that transformation and make it give a null, I mean, that's just insane. Like you can't logically rectify aberration in air with transposing the velocity to a different reference frame when it's in water to make it predict nothing. You have to be consistent with it. And that's why these don't apply. This is why this experiment is so important and straightforward, because it's literally just water and the time it takes for light to traverse a distance based off of its induction rate. It's, it's very, very straightforward. And then again, just to reiterate, the original prediction had nothing to do with ether components. There's no ether equation in here. This is just cosines and Snell's law. So the argument, which we've already went over ad nauseum, is that, the photon or the wave, or actually I need to change this, the photon or wave, shout out to my boy Franco, however you want to conceptualize light, that it has a horizontal velocity component under transformation. And it's like, okay, well, if it has that in air, then there's no aberration to begin with. So either your Lorentz transformation is invalid or aberration's invalid. We have to pick one. We can't have both. All right, then we have mctune.net / what is this website? 1 second. mctune.net / relativity. If you scroll down to his section on relativity, he has a section for Aries failure. And we went over the conclusion about the hypothesis being untenable. But what exactly was the hypothesis? Did the hypothesis have to do with isolating evidence for ether and rotation? No. Did it have anything to do with the existence of the motion of the Earth in the ether? Well, it had to do with the motion of the Earth for sure. But he says nothing about the motion of the Earth can be concluded or of the ether for this experiment. Well, that's not true, because what he also has here is the English translation of Klinkerfues' paper. And it says here a special note, I have not read this yet. This will be extremely pivotal moving forward when we watch an upcoming video from Fizeau talking to Tune about this experiment. But anyway, he's got this citation here that he has not yet read that I went through and read, and it actually refutes every argument that was put forward. Like now we know exactly how and why Klinkerfues derived this experiment, what his thoughts were, what it was in relation to the ether, and as far as those mechanics go dynamically, and what it was about. So everything put forward here is false. And he really should have read this, because he's going to be at a huge disadvantage when he talks to Fizeau here, and we'll watch how that played out. Next, we have flatearth.ws with a little meme here about the ether not being detected in horizontal components, blah, blah, blah. And that the Earth's motion, we already knew Earth's in motion, blah, blah, blah. Well, no, they didn't. The purpose of this experiment was to determine that. And the fact that there was no angle change means that the Earth is stationary. So this meme's, you know, retarded too. There's nothing of value in there. If the angle is unchanged, then there's nothing. I'm not going to make you guys suffer to listen to FTFE. We did that on the first playthrough for continuity. But basically, his argument is the same in that there's no ether. Therefore, we're all retarded, in short. So you guys can check that video out if you want. But he's just ignoring the refractive index and makes it all about the ether. There's still supposed to be an angle change because there's a timing difference. You can't argue that the speed of light is, oh yeah, if you read his comments, you'll see his take is that the speed of light is different, but also the same in water. Like, it's preposterous. And then we have this lad over here who's a newcomer to the conversation. I'll go easy on him because his video was pretty much zero impact and he didn't really have anything to offer. But if you check out his video, he goes on to just say that he thinks that the speed of light in water doesn't change. So he's predicting no angle change, which we showed is incorrect, an invalid interpretation. We have I Can Science That here, who does a video on the same and offers absolutely no explanation to it as well. You guys can check that video out. And then, of course, we have the... so when I was doing research for this video, I went to YouTube and I typed in Aries failure because I wanted to see what the average Joe would see when they go to YouTube and Google Aries failure, to see what kind of interpretations and refutations and all of that would be out there. And I came across two new channels that offer some explanations to Aries failure. So we're going to watch these. These are some flat earth lads. So this channel is, I forget the name, but I'll link it here and we'll play the video.
Aries experimental data appear.
So he actually plays a couple of clips from FTFE's video. So we'll get the truncated version without watching 5 minutes of FTFE. You're welcome.
To show no apparent motion of the Earth, as the starlight did not behave the way expected on the heliocentric model. The video that I've used the past couple of days is from a channel called Flat Earth Talk. I just want to ask, what is wrong with the guy? Was he dropped on his head as a child or something? Because once again, he's come to completely the wrong conclusions. Aries experimental data appeared to show no apparent motion of the Earth, as the starlight did not behave the way expected on the heliocentric models. Aries experimental data appeared to show no apparent motion of the Earth, as the starlight did not behave the way expected on the heliocentric model. The 1871 experiment by George Airy was an attempt to determine the drag on light that would change the stellar aberration of a suitable star that was directly overhead. However, his entire experiment was based on the false assumption that light needed a medium to travel through, commonly referred to at the time as the aether. Airy filled the telescope with water and observed the passage of light into the telescope.
And again, remember, we went over, had nothing to do with that as the mechanism.
As aether theory indicated that a telescope filled with water would produce different effects than one filled with air.
Yeah, this guy doesn't do any commentary on it, so I'll just kind of read what he's doing. So we Googled Fizeau's experiment, where we just talked about the velocity of light in a moving medium. So he says, there is no such thing as a partial ether drag. There is simply ether drag, which is quite literally just stating that the movement of the medium, such as air or water, will affect the speed of light, the allegedly universal constant and foundation of special relativity. Which is why when the 7th Astronomer Royal Airy Bedell, or George Bedell Airy, failed to detect a difference in stellar aberration.
Aries experimental data appeared to show no apparent motion of the Earth, as the starlight did not behave the way expected on the heliocentric model. However, the results were skewed based on the false assumption of the existence of the luminiferous aether. The experiment became known as Aries failure, as no motion was detected, as no motion was detected, as no motion was detected, as no motion was detected. But the actual result was the same as yesterday's Michelson-Morley experiment, and that was determined that the aether did not exist. But the actual result was the same as yesterday's Michelson-Morley experiment, and that was determined that no motion was detected.
Okay, here's the deal. Fizeau's experiment proves that a moving medium affects the speed of light. This comes to be termed partial ether drag, which terminology is ludicrous for the reasons that I've already given. Ether drag is already a confusing term because it's a concept being used in a heliocentric mindset, which does not make sense. What ether drag actually means is that the medium, like water, can be shown to slow down light. Heliocentrists think that this means that the rotating ether is infused into matter or something, and that sort of thing, and so that the denser the matter causes a noticeable light drag. To be completely honest with you, heliocentrists do not themselves know what they believe in, as evidenced by the man featured so prominently in this video. The arguments are inconsistent and logically absurd. Fresnel's ether drag coefficient is still used today. As we just went over, it's still used in inertial navigation systems, for example. So ring laser gyroscopes. So here we have a comment where a guy is asking about the speed of light in a medium, and he's like, well, not really. Light itself whilst it's traveling, always moves at c. While this is happening, it's being absorbed and released at different speeds. So he's like saying it changes, but it doesn't change. And this dude's like, thanks. He gaslights his own soul. He thanks him for his response. And then a quick cursory Google search tells you that yes, light slows down in a medium.
Have you ever had a simple question ruin your life? Of course you have, right? Like, it's perfectly normal to spend months and months doing nothing else but obsessing over a question that no one else cares about. Like, does light actually slow down in water? I know you probably think the answer is obvious, light definitely slows down, like we learned that in high school, but I've never really believed it. Like, it just seems odd. In Einstein's theory of relativity, the speed of light is this super fundamental thing. Got the laser meter. And now what I'm going to do is that same experiment again. I'm going to test how far this meter thinks the distance is from the top of this jug to the bottom. And I'm going to do it once without water and then once with water. Okay, it gives me 11.2 centimeters. If the old distance is like 11 centimeters, then the new distance should be approximately something around 14.5. Okay, so if the result is like approximately 11 centimeters, then that means that the speed of light in water is about the same, whereas if it's about 14.5, then it means that the speed is significantly slower. So let's see. Okay. Aiming it for about the same spot, and okay. I think that's a positive result.
All right, very cool. So the interpretation that light is the same in the medium, not valid. There is a timing difference. All right. All right, so there's a couple of other videos here, but I'm just going to skip to the last one because I've kind of watched these a couple of times and I'm over it. But if you want to watch the other videos that are in the presentation, you can click on the Obsidian link that I have, and all these are embedded in there, so you can watch those there. But yeah, we're going to listen to Fizeau and McToon discuss Aries failure and all of the things that Toon didn't read in the paper that he has as evidence to support his position turn out to directly refute him and make him incoherent. So here we go.
I have a question.
Yes.
Is that okay? They tagged me to come in here and ask you because you said you wanted to just ask me about my question. So if you're familiar with Aries failure, I just want to know if you have an answer as to why the aberration angle in Aries telescope didn't change when it was filled with water.
Yes, because so the Klinkerfues' undulating theory of light predicted that as the Earth moves through the ether, the luminiferous ether, that the light would slow down and that it would then hit the side of the telescope. And so when that did not happen, then they were kind of confused because they were looking, they thought the undulating theory was correct. And so it confused them that it didn't work. So what happens is the light slows down in an external reference frame, but within its own reference frame, it's still going the speed of light.
So what about the emission theory, though? Because isn't that what we use now?
Yeah, it's essentially the emission theory. Yep.
But in the emission theory, the light gets slowed down by the water. So it's still a slower velocity.
Yes. So the emission theory. The emission
ratio of the velocities.
Yep. So the emission theory is essentially, I said essentially because that's within our reference frame. But general relativity, special relativity is the better understanding of it. So within special relativity, the light slows down in the reference frame of the water from an external reference frame. But within the reference frame of the water, which is the only place that the light is moving, it's still moving at the speed of light. So inside the water, it's moving at c.
Wait. In the lab, the telescope and the water and the Earth all move the exact same. They're all a part of the lab frame.
But the light travels at the speed of light in water when it's in the water. And it's a three-dimensional thing, not a one-dimensional thing.
Klinkerfues, well, he believed in a static ether, but that's kind of like a straw man anyway, because the description that they believed in that would explain it with ether was one in which the ether caused the light to move. Because you can't tell just looking at the telescope and the light by itself if it's Earth or if it's the starlight that's moving. So they said, okay, let's put water in it, because the formula for the aberration angle is tangent theta equals Earth velocity over light inside the telescope velocity. So once we put water in it, that second variable, the light inside the telescope velocity, will be a smaller number, so the tangent theta angle should be a bigger number. It doesn't matter which model you're using, because that's the formula in every model. That's the formula we even use today. And we know that light slows down in water.
Yeah, like I said, it's still moving at the speed of light in the water, but you apply special relativity, and right, they're different reference frames. So,
but there's nothing moving at relativistic speeds. This Earth's only moving like 66,000 miles an hour or 30 kilometers a second. It's nowhere near the 10% or more speed of light needed to apply relativity. Any relativistic calculation is going to be equivalent to the small angle approximation, which is equivalent to the tangent theta angle equation at these velocities.
Yeah. Yeah. So yeah, you're just going on pure emission theory and not taking into account special relativity. That's okay. But that's not obviously what works. Since the motion of the Earth has been confirmed externally to that previously. So this one thing contradicted the emission theory, but it didn't make any of them say, "Oh, I wonder if the Earth is not moving," because there's several other things that confirm that the Earth is moving. So
well, if in the frame of the water, the light doesn't change speed, if you say it's still C in the water, at the two ends of the water, there's a speed change. So in the water, it would be C plus or minus V, because we still know that the light has got a drift, a sideways drift on it, because that's the only way it reaches the eyepiece center. That's why the tilt has to be applied. So if in the frame of the water, it's C plus or minus V.
But
that still breaks relativity.
No, it doesn't. Is the water also moving laterally?
Everything on the Earth system in the lab is moving laterally if Earth's moving.
There you go.
But if it is, then it moves out from under the starlight, and that's why the telescope would have to be tilted. So when you add water, the tilt has to change because the velocity of light is different in the lab frame.
Given how the length of the telescope, how many nanoseconds will the light be passing through the water?
Well, that's not really the issue. The emissive theory without special relativity is, doesn't explain it. And so he's right. He's right on that the emission theory. So if you read the beginning of especially if you read the beginning of Michelson-Morley, it talks about the emission theory of light, which kind of goes back to Newton. It's popularized back then that it was particles or corpuscles of energy, and they were emitted. Thus the emissive theory. Yeah. So
we still use that theory today.
Also, let's not forget now that we have instruments, and even in the amateur days in the late 19th century, that you can measure the stellar aberration, which is precisely the shifting of positions because of Earth's motion around the sun.
Yeah.
But there's only two variables in the formula. That's what I'm trying to get at. The formula is super simple. The tangent theta angle equals Earth velocity over light in the telescope velocity. So if you change either of those two variables, the tangent theta angle has to change. You can't have the same tangent theta angle if you change the two input variables.
Yeah, and where you missed the part where you need to apply special relativity.
Can you provide any links to any resources that show a calculation that fixes it in with special relativity? Because the change, if we measure it in the lab frame, that's where the tangent theta angle approximation is used. They don't calculate it in in some relativistic coordinate system where you apply, where you take the frame of the water and say C is C in the water. We know dynamically that the water slows the light down, right? Because if you go to the frame of the water and say the speed of light is C in the water, then as soon as the light leaves the water, it's speeding up and it's exceeding C. So it would exceed the speed of light in that frame if you force light speed to be C in the water. As soon as it leaves the water, it speeds up past C. You can't have that.
Yeah, and like I said, if you want, I can provide them. I don't have them handy though. Like I said, and to one more time. One more time to reiterate that the water is also moving laterally. So okay.
There's a second problem with it too. Because other than violating special relativity by forcing light speed to be C, there's also Snell's law, which states that if light hits a refracting medium such as water at a non-perpendicular angle, it will introduce an additional refraction angle into the system. And so if the light travels vertically, it won't do that. But if the light comes in at an angle, it will do that. And if the telescope is tilted and the light's coming in vertically, when you add water, it would have to change the angle from that reason as well. So the fact that Snell's law being applied in the system actually doesn't create a real physical refraction angle in the water means that the light's already coming in at that angle as well. And the only way it can already be coming in at that angle is if Earth is stationary.
Are you talking about the interface between the lens and the water? Or the interface between the lens and the air?
The lens, when the light enters the water, right? Because you have a stream of light coming, what's assumed to be vertically, right? If it's just starlight streaming towards the telescope. But if Earth's moving, you then have to tilt it. Well, when you tilt it, it's coming in vertically and it's a non-parallel or non-perpendicular surface now because the telescope's tilted.
But when you tilt it, you've now made it straight in relationship to the light path.
No. It's already straight. The star's at the zenith.
Well, the star is sigma.
It's a zenith telescope. It's a zenith mount.
No, it wasn't. It wasn't straight up. It was at an angle, right? But it was I forgot the name of the star.
Well,
it
wasn't. Zenith Mountain Telescope. They used 2 spirit levels to level it off to make sure it's at zenith, pointing to the true position of the star, as according to the almanac. And then they look in it, and then based on optics, they see what the arc-second correction is needed to center it, and then it becomes tilted.
Okay.
But then when they add the water, since it's tilted, now there should be refraction introduced from Snell's law as well. So there's actually 2 sources of additional angle correction that should be input, but none was needed.
Did you calculate the predicted change in angle?
Yeah, they said they believed it would be close to 30. I mean, if you just take the 20.2 or whatever it is and do 4/3, because the speed of light in water is 3/4 that of C, then that means the angle change would be 4/3 of the standard angle. So since the standard angle is just over 20 arc seconds, it bumps it up to like 28 roughly, 27, 28, close to 30. But it didn't change. So in order to analyze it, you can if you make the Earth stationary, right, and you add velocity to the water to change it to catch up to that extra angle, you'd still need a correction angle. The only way that you can make it work is if you treat the system in which you're measuring it in as stationary, and you treat the light as already coming in at that angle. So you have to use a geocentric coordinate system in order to make the physical observation as was made work.
All right, well, sorry, I was handed an orange cat. Thank you.
That's what that noise was.
Yes, that was that cat named Turtle. He was cranky because the dog is in here, and now the dog's trapped in here. Anyway, the water is moving, and the key part of it is that the water is moving along with it. But anyway, if you want, I can send you some additional resources, or we can set up a time to have a conversation.
Yeah, please send the papers. I mean, because you can't.
But like I said, I don't have them handy. So I don't have them even in my notes.
If you say the water's moving with it, though, you can't analyze the Earth as stationary for the transformation with respect to fixed stars and have an Earth that's not fixed. You're making both velocities. You're putting both velocities under transformation, and that violates Lorentz symmetry, even under a relativistic paradigm.
All right, so what is your position? Are you a geocentric glober?
Concave Earth doesn't have this problem.
Yeah, so Aries failure proves geocentrism. It has nothing to do with shape.
But you didn't answer the question. Are you a geocentric glober?
I'm here to discuss shape. I'm here to discuss motion.
Okay.
Right. So I'm a Bible believer.
I'm here to discuss shape.
But you can't have heliocentrism either. So
Robert Sungenis aggressively disagrees with you.
Well, I think that the Bible has always historically taught geocentrism, and it always was taught geocentrism. People didn't stop believing in it until the modern era. Even the church opposed it when it first came out as a heresy, and they were right, because the Bible clearly teaches it. They had to adopt modern post hoc explanations and eisegesis of the text in order to insert heliocentrism upon it. But it clearly teaches geocentrism, and that's what the experiments show as well. The first historical famous one being Aries failure.
Unfortunately, the movement of the Earth is
I appreciate the papers.
Yeah.
Now, unfortunately, as Mike said, the motion of the Earth has already been established by other means.
Yeah, previously.
By what experiments?
It's not subject to. That's not the subject of the experiment.
Yeah, I can list them though.
So, wasn't the subject of the experiment? They already had experiments, and then he's going to go on to list parallax, which we already went over. Is a measurement. It can't tell you which is moving, sky or Earth. The whole purpose of this experiment was to provide definitive proof on the physical nature of the aberration, which is why he was introducing a medium, as he laid out in the first paragraph of his paper.
James Bradley in 1727, Aberration, which of course is this topic, right? So then you asked me. All right, I won't list them if you don't want me to.
No, go ahead.
Okay. Of course, parallax from Bessel in 1836, I think. You've got Vogel and Schneier
That's not mutually exclusive. It works equivalently in a geocentric paradigm parallax.
How about you let him finish?
Okay, so obviously he doesn't want me to. He doesn't want me to finish. Thank you. We'll talk to you later, but not now, since I don't get to finish.
All right. God bless you, man.
Don't want to hear it.
I just
don't care.
Didn't want the,
don't care. Don't care. When you talk like that, I don't want to hear about your God. I'm not impressed with your God.
Yeah, so right around there is where Toon ran out of ammo and then, found a reason to boot him out, because the list of proofs that prove heliocentrism as a, mutually exclusive are not actually mutually exclusive, and it's just parallax and stellar aberration. All right, so that concludes the Prezi. Oh.
Dude, is there an exit?
Shouldn't be.
I love how he just interrupts him just to a little bit, and it's just nope, end of conversation.
Yeah, it's like, dude, you don't realize you're listing things that are, one, don't actually prove it, and two, the purpose of the experiment was actually to determine if aberration is a physical effect. Turns out it's an apparent effect. Ta-da!
And it's all you are very technical, but just like he says, I'll give you the document so you know what I'm saying.
Yeah.
Or gives him some 400-page scientific document that. So it's always this crazy scientific technical explanation.
Yeah, and then you get into the explanation and you find out it's not even technical, it's just mathematical jargon with no physical meaning that first has to assume the correctness of the velocity in question, which is, as we've all learned, is a logic fallacy, right? You're reifying it, you're assuming it, you're presupposing it, you're begging the question. You're in a haunted hayride conundrum,
Yeah, it's affirming the consequent. Logical fallacy of assuming a particular cause must be true just because its expected outcome is true.
Yeah. And exactly, dude, affirming the consequent. And as the boys laid out in their book, Syngenis and Bennett, it's like if the effect is false, then the cause is false. One has to follow the other. You can't retroactively, make the thing that's falsifying your position proof of your position. That's insane.
It's quite amazing, actually. Is this kind of like the Marcus and Morley, where they what do they do? They shorten the apparatus or something like that? I don't know.
Dude, it's exactly that. That's the exact mathematical framework that they use to answer it. So obviously, link contracting starlight from a telescope sounds absurd, right? So they'll hit you with these velocity vector summations, where they're transposing the assumed velocity into the frame of the incoming light, which would make it equivalent, but also the Earth has to still be in motion so that it gives the null reading. So it's actually just physically meaningless for them to do that, because the actual velocity composition that they would, when we apply relativity to, when Toon kept saying, you got to apply relativity. Well, we applied relativity. Remember those figures and how they turned out? The gamma factor changes the equation by 2/10 millionths of an arc second. That's not a real thing that could be quantified, right? It's identical to the classic. Throwing the gamma on there does absolutely nothing. That's why they have to do the absurd velocity vector summation and add a velocity to the incoming light as it's coming in the water. But if you did that in air, you wouldn't even have aberration. So that's invalid.
sorry, I'm like a bit of a dummy on this thing.
Nope, it's all good, man.
And that's the thing,
It's all good, bro. You're good. What's up?
And that's the thing, like, because if he gives that counter argument, I'm just like, I have no way to like even comprehend what he's really saying. But what was I going to say?
Well, to help you out, he doesn't even really know what he's saying.
Yeah,
So
jargon.
Yeah, it's just a ruse.
I'm just thinking, because they change the way the light is coming in, the angle of the light coming in, does that have implications to other things?
No, it's it's just a way for them to explain how they could be in motion but not have the effect of it. Because the implication is that the Earth is stationary and that the light already comes in at that angle.
But I'm just thinking, like, if they're changing the angle of the light, wouldn't that mean the angle of the star is, the position of the star is different? I don't know, I don't know. I'll just shut up.
It's all good, dude. It's all good.
I think what you're saying is like the true position of the stars is somewhat unknown because we're only receiving the light at a particular angle.
Yep.
That's all we can know.
Yep. That's true.
Is there
because of it? Oh, sorry.
Yeah, this is what I was trying to say before. Like, people say, "Oh, like I see this star at zenith, or I see the sun at noon," and all this stuff. I'm like, well, look, to be fair, you're looking at apparent positions no matter where it is in the sky. So its true position, unknown. Okay. But you can document the kinematic position, right? But it doesn't explain like where it's at, like actually. You're just like documenting the the periodicity, I guess is what you'd call it, right?
100%. Exactly what you'd call it. And that's all that's all this has ever been.
Bingo.
Yep. And then go ahead.
Because this is done in the 1850s or something. Has anyone replicated Airy's failure since?
Ooh, it's a good question. I have not found any modern replications of it.
Yeah, just weird how such a badass. I don't know. Is it an experiment? Because
yeah,
I thought an experiment. I manipulate the cause. The cause is the star. How do you manipulate the star?
Yeah, so you got the independent variables would be the speed of light. The control would be the air or adding a medium, and that would be a manipulation of the independent variable, which would be that speed of light. So it is definitely an experiment. If you like in the most basic sense, I mean, everything right there is there, and then the outcome, which is the angle, you alter the dependent variable by altering the independent variables. So the angle change will be changed when you add water like that. So it's absolutely an experiment. That's why it's significant, because the ones where you just make the observation in air, that can't tell you which is in motion, right? It's not, that's actually just an observation. There's no IV/DV. You could make an argument about maybe perhaps time of year in relation to the position and deviations is a form of an experiment. But even that though cannot tell you which is moving. So it's like, it's simpler to just think about that as just an observation. And then when they're actually introducing a medium to change the controls, that's where you would, that's where it's an experiment.
I'm just thinking the cause of the light is the star. Like,
that's irrelevant. There's light. That's all you need to know. You don't need to know the cause of it.
because I thought you would have to really like trace the light ray all the way back to the star to understand where it's really coming from. And
No, because it's not about the. Well, no, I see what you're thinking, but it's not about the distance necessarily from the star to the Earth, right? It's about the timing difference in the speed of light in a medium versus like the physical, caused by a physical motion. So the only part that's really relevant is the 33 inches of the telescope that's in water.
yeah, I'm just thinking. Yeah. I'm just thinking, like, is there anything they can do to the water to like slow it down even more, like add salt or something? I don't know, like.
Absolutely, you could use a different medium, like what's his name used turpentine. It just has to be any translucent medium.
And what did turpentine slow it down even more? Or how'd that
Yep.
work?
Yep.
Mic check, mic check.
Yo, loud and clear.
Aren't clear? Hey, is Witsit here?
Not sure. What's it? You there, brother? Seems like a negative, Ghost Rider.
Alan, you want to ask my silly but also really serious question now?
Only if it's a super hard-hitting question that's really going to cut to the core of the issue and make actual progress in the movement.
Yeah, trust me, pal. You don't have an answer for this one.
Oh yeah, what do you got,
All right,
Gally?
so if all these guys, Arago, Mickelson, Morley, Airy, if they were all measuring the ether, how come I've never seen any ether measurement or any type of measuring apparatus for the ether?
Oh my God.
Answer that. Bud.
Oh my God, Gally. You got me. The exact same can be said for the velocity of Earth, and only smaller velocities are measured. So only smaller ether velocities are measured, never the velocity of the Earth. Good day, sir.
All right. You win this.
So it goes both ways.
Indubitably. Indubitably.
I got one.
What up, G?
How come every apparatus that they create to measure the motion of the Earth, then ad hoc, retroactively, years later, gets transformed into an ether measuring device?
Science. It's just the natural progression.
No, do you have like a PhD or something, or like?
No.
Put all this together and understand this, like.
No. I have a GED.
GED.
Yeah, basically when you drop out of high school and you get like a little certification that says that's just as good almost, or whatever.
Sorry, you're like so intellectually. Like I'm just what's the word? I'm like, I'm a bit like gobsmacked with that presentation. Like,
Well, I've dedicated a lot of time to reading and research on it, so it's just that's a reflection of it, right? I didn't just read this and like one tap it and it just made sense inherently. Like this is through a long process of it. I'm just presenting it, to the boys, making it digestible so that everybody can have a chance to learn and understand this, because the only explanation that they give is basically just to gaslight you and make you think that you're too stupid to understand it. And it's like, okay, well, let's get into the particulars of what you're doing with your math transformations. Let's really unpack what's going on here and understand what you're physically trying to represent with what you're saying. And does it make sense? Does it apply in all scenarios? And it's like, no. Then you find out they're being selective. You find out that, you know, the actual prediction matches the classic prediction. So there is an angle difference, but it's like all these people are so committed to the correctness of relativity and mainstream interpretation of cosmology that it's like, you know, they either don't see it, they don't want to see it, or they're just going to come up with whatever they need to gaslight you to make you think that, you know, you don't understand that light slows down in water. And it's like we had to take we had to take it to this level, you know, to help break it down or whatever. But it's like this is what we're up against because the mainstream pillars of cosmology and physics are held up by special relativity, general relativity, and quantum mechanics, specifically QED.
Yes. So their whole thing, what they're relying on is that light is coming on that on a slightly different angle. Which begs, now I would question, like, how do you know that? You know?
Yeah, exactly.
Like, it has to be coming in on that certain angle for that mass to work, but how do you know it's coming in on that angle? Like,
exactly. And that's the assumed, you know, oh, the 90 degrees, this is where the star has to be, you know, and that's all in relation to the coordinate system and the positions of the stars and where they are for the ground position. And when they go to confirm the distances and they go underneath the zenith of a new star and they look at it and they're like, okay, we should be directly under it. And then when they're not, they're like, okay, we have to make an adjustment. Like this is all literally the same thing. And it's like, there's no actual ideal position for it. It's all arbitrary, but trying to make it conform to that arbitrary position so that the coordinate system is useful, and to make it more accurate with the, you know, you can introduce these types of corrections. This is where this is all coming from. And yeah, and like trying to interpret that also through the lens of, you know, we're on this ball Earth and we're moving through the cosmos around the sun. It's like trying to merge all of that together is like the end product of all this.
yeah, but I guess I'm thinking about it because, as I said, how do they know the light's coming? You know, the same thing you could say for us. How do we know the light's coming in on that? You know?
Oh, because when you introduce water, it does. There's no difference. That's how we know.
Ah, okay. I thought. Wait, I'm confused. I thought when they put water in it, they had to angle it a little bit more. Or am I thinking about this the other way around?
That's what they were supposed to do. They were supposed to have to angle it more. And Airy didn't actually have to tilt his telescope. That's what there was actually a correction I needed to add to for clarification for the convo with Fizeau and Toon, where he was arguing that Airy did have to tilt his telescope. That's not how the measurements were made. It was a zenith mount. And when the water was introduced, the star was supposed to be moved in the micrometer. So like, you know how it was in between these slits for the grid? When you introduce water, it's supposed to be physically in a different grid. That's how they were making the measure. That's how they were making the measurement. So at all times, yeah. So at all times, the telescope and the water are all flat and level relative to the incoming light. And then when they introduce the water, there's no change. So that means that the light that they're observing in air and in water already comes in at that angle.
Okay.
And it's like, it's doubly bad that they didn't have to tilt the telescope.
that's what I was going to say before. Like, the mental gymnastics and the defending and the why do why do they defend it? Like, why do they why do they care so much?
Well,
I don't know. I just don't get it, I guess.
it's like a priesthood, right? Like, imagine, your religion was, taught through cosmology and mathematics instead of like a foreign language and an ancient scripture text that nobody else can read. And your interpretation of the sky and its correctness is facilitated through the lens of these equations and how to apply them and these rules and regulations for all that. And, when you go through that process and you're committed to it, you're super into it, right? Like, a priest isn't going to all of a sudden be like, oh, you know what? Everything I'm doing is pretty, DS. And I don't really know anything about this whole God situation. So I'm just gonna dip out. And it's like, well, what are you gonna do? How are you gonna make money? You're a priest. Like, you have one specific, thing that skill set there. Like, you're just gonna be a priest but not believe in God. You know what I mean? So it's kind of like, once you go through that lens of interpretation, you're just kind of committed to it.
True. I guess I'm like, I know that within myself that I can challenge my beliefs, and I don't cling on to anything.
Yeah.
But yeah, if you go to school, you pay all this money, you get.
Hold on a second. Hold on a second. Right here, we have an actual PhD in the chat gaslighting people. John, the only way they'd have to tilt the telescope is if there were an ether. John, does light slow down in water? Yes or no? John, are you there, sir?
He said light slows down on water.
Oh, am I? Oh, I didn't realize I could talk. Sorry. Okay. Hold on a sec. Let me, there. Okay. Yeah. I mean, that's Flurfs always misinterpret the Airy failure thing.
Stop with the ad-homs. Yes or no question.
Was that an ad-hom?
Yes. I don't care about what you misinterpret, Flurf, dog shit. I just asked you a direct question, yes or no. So light slows down in the.
I said yes.
So light slows down in the water. If the Earth is moving out from underneath the Earth, because of that timing difference, there's going to.
There is no. See, that's the thing in relativity.
Do not interrupt me in the middle of my sentence, dude. That is not going to happen here. All right. So when the light slows down in the water, there's a timing difference. There's going to be a greater distance that the Earth can travel before the light hits the observer. That's going to increase the angle. This is how refraction works. We already noted that. We know there's a timing difference, and we know that if the Earth is physically moving, that's going to produce an angle change. This has nothing to do with an ether. The ratio for aberration is the velocity of Earth, the assumed velocity, and the speed of light. There's no ether variable in there.
My turn? Yeah. So see, the thing that you keep putting in there is the Earth's moving. There's no such thing as absolute velocity. When you talk about the Earth moving, you're implicitly assuming that it's moving through an ether, in which case the light would bend because of the slowing down. But the Earth isn't moving through anything. There's an Earth and there's a star, and the distance between them may be getting less, maybe getting larger, maybe getting smaller. It doesn't make any difference. The light comes directly to the Earth from the star, and if it slows down on the way, it slows down. It doesn't angle off because there is no angular motion. There's just an Earth and a light source, and the light comes directly to the detector. This is explained in lots of videos. You can look them up online. Okay. You probably take issue with them, but it's that simple.
Okay, so your argument is that stellar aberration isn't a mutually exclusive proof of Earth's motion. It doesn't matter if motion is absolute or not. Dynamically, if you're moving out from something that's moving slower, you're not going to land in the center of it. So it doesn't that doesn't matter if motion is absolute or not. This doesn't have anything to do with moving through an ether or an absolute reference frame. That's actually the purpose of this experiment, and that's why it's so important, because irrespective of any ether mechanics, this is a physical effect that is dictated by Snell's law and the and cosines, like just the angles, right, and the ratio over the velocity for the aberration. So there's no ether mechanic involved here. And what you said about angular motion is irrelevant. This applies to linear motion. Angular doesn't matter.
Well, you said a lot of stuff there, but it's just not true. It's very simple. The only time in which you would actually concern yourself, well, the only time you would concern yourself with an Earth moving transverse to the source of the light is if the Earth was moving through something that could make that kind of a velocity meaningful. And that's what the experiment was intended to do, was to detect the motion of the ether by seeing how much the light deflected when you had the water there, because that would mean that the Earth is moving transverse to the source. Because they didn't see that, it was one more piece of evidence, either, depending what you like, that the Earth isn't moving relative to the ether, or that there isn't any ether. But just like the Michelson-Morley experiment, the Airy failure, as it's called, was a failure to detect the Earth's motion through the ether. It's that simple.
Okay, John, we're going to read a little bit from Klinkerfues' hypothesis, which was the inspiration for Airy to follow up on the significance of the alleged results from Klinkerfues, and we'll see exactly what the purpose of the experiment was here. This is from Klinkerfues. 1 second, I'm going to get some water.
I don't know what that is. Klinkerfues, is that what you said?
Yes, this was a German physicist and astronomer in the 1800s who did the first iteration of Airy's failure, and he said that he actually measured the aberration angle when he introduced the medium. The significance here is the derivation for the ratios for everything and the purpose of it. Right, because you made a lot of claims there. So we're going to get into the exact specifics of why the experiments were done and why this was a failure for Earth's orbital velocity and had nothing to do with the ether, because you keep specifically saying that this is an ether velocity issue. First, they were testing for a velocity through an ether. Now you're saying they were testing for a dynamic ether. So you're all over the place in this, but we're going to get real specific and look at the actual paper here. So this is Professor Klinkerfues, German physicist in the 1800s, who was prior to the Aries aberration experiment. So the aberration of the fixed stars. Under the term aberration, two different processes are almost always combined in the writings dealing with this subject. First, the delusion, which are subject by the direction of the ray owing to the motion of our point of view, and which are quite comparable, is that which we fall in a fast-moving carriage or a railroad over the direction of pouring rain. Secondly, the real change in the direction of the ray, which is also caused by the movement of the Earth. The former may be called a psychological effect, and the latter the physical part of aberration, meaning the actual angle change due to the distance that the Earth moves out from underneath the light that is incoming. Right? Now, however you want to interpret that, doesn't matter. As long as there's a timing difference, there's going to be a distance change, which is going to create an angle change. Confounding these two, the different effects under the concepts of aberration, by aberration being understood to mean the total and apparent real change at the direction of the ray caused by Earth's motion, has nothing less than a favorable treatment of the object. Even the consideration, the expediency of the sharp limitation of the concepts, and every terminology would suffice to find the combination of the two processes, which are related by a common origin, but incidentally different, not advantageous, but also adds to the two parts of aberration, are a different difficulty of treatment. Then he goes on to say here, now this is important, pay attention. This remark, essentially pronounced by Fresnel's words, Fresnel in other words, gives us the opportunity for a very important theory of aberration. the way in which the physical aberration is altered when the deflection by reflection or refraction, or what appears to be the quite small influence of Earth's motion by refraction or reflection. By this, we may be, since we obtain by way of experience independently any hypothesis about the translatory motion of the flow or the ether, we have the same time gained in the experience of the latter. Oh, no way. So independent of any ether effects, there's still going to be a difference. Okay. But also what Fresnel proposed, right? Like, we're not going to discount that yet, but, independent of this, there's still going to be a difference. On the basis of the proposal or the proposition according to which refraction and reflection are explained in the wave theory, it follows that the influence of Earth's motion on reflection and refraction, just as it should when the ether, both a medium in the world of space, would be quite free of transitory motion, or rather free as merely the partition of the refracting or reflecting medium were moved, without being accompanied by the transitory movement of the ether. We conclude that either the ether is really at rest, or that its transitory motion has no effect whatsoever on the appearance. In this dilemma, we find the former assumption reprehensible for various reasons, so we decided according to experience for the second, but we are also able to prove the latter, that is, independent of the physical aberration hypothesis about the transitory motion of ether, in harmony with the fundamental doctrines of wave theory, but we will not refrain from doing so to note that this independently extends only to the phenomenon which, like the present one, only has to do with the position of the plane waves and their normals. The diffraction phenomenon, for the example, which other conditions are still decisive, one cannot assert the independence of the phenomenon from the transitory motion of the ether. It is a known fact, or it is known that Fizeau's acumen in diffraction phenomenon has recognized a mean of measuring the transitory motion of the ether itself in a hypothesis which Fresnel, which I will cite later, which I have the citation for, but I think that's sufficient. So what he's saying here is that independent of any ether effects, the cool thing about this experiment is that there's going to be a timing difference when we introduce a medium, and that's going to tell us definitively which is in motion. So no more about, oh, well, this is about a failed ether experiment. They failed to find the ether. Michelson-Morley failed to find the ether. You're going to have to substantiate that. Where in these documents do they say we failed to find ether? Where in Michelson-Morley, 1887, it's not that big of a paper, where does it say we failed to find any ether? Can you substantiate that? If you cannot substantiate that, then you don't have anything to contribute to the conversation, and you're going to have to move on to a new point and address the fact that if the Earth is actually in motion and the cause of aberration in air is that motion, when you introduce a medium, guess what? There's still going to be an angle change because now there's a timing difference. So irrespective of any mediums or absolute motion, this is your proof that the Earth is in motion. Now you're saying it's not proof, and that this is somehow ether dependent. Go ahead and respond.
Wow, thank you. So I'm not going to blather on for long here. I'm just going to say once again, I don't know how many people found that compelling. I know I had a hard time following it. I'm not even sure what in the end he's saying. Maybe everybody here is smarter than I am. But I think that was not a compelling reading. I'll just say one more time. Several times in there, you talked about the motion of the Earth. What do you, when you talk about the motion of the Earth, what are you talking about?
Motion of the Earth relative to the stars. The velocity, the aberration angle prediction is the tangent angle is the velocity of Earth over the speed of light, which gives a theta of 20.5 something arc seconds.
What's the theta? How do you
stop? The theta is the angle that's measured for aberration. And when you ratio that against the speed of light, you get 30 kilometers a second. We can look at a little diagram here to show you. So when you say, what are we talking about? It's aberration, dog. Do you not know what aberration is? So the arctan when V over C gives you the theta, which is 20 arc seconds, which is what they say stellar aberration is. So they're drawing the correlation that this is evidence for Earth's motion. Here we have in 1889, Wilhelm Well saying, hey, these experiments, the experiments that give positive results for Earth's motion is the aberration of light of fixed stars. And then he goes on to say the experiments that give negative results are the attempts to see whether the influence is of refraction of the light of the fixed stars. So this is exactly what we're talking about.
Am I the only one hearing an echo?
Yeah.
Sorry, bro. Am I the only one hearing an echo here?
Somebody else was asking me about an echo earlier.
If you have the other screen share, I had that too when I was looking at the other stream. You have to just look at the second stream up at the top, I think.
Okay.
That's what I had.
Yep, no worries. But yeah, these experiments were about determining if the aberration, if the cause of it was Earth's velocity. So if you're taking the position, dude, go ahead. Just if you can, if possible, make an actual argument against what I'm putting forward instead of saying, I don't find it compelling. I found it confusing. What was confusing? What do you need clarification on? How can I help you understand my position better so that you can formulate an articulable argument against it that isn't an appeal to, feigning ignorance? Because you have a PhD in this, so this is pretty straightforward. You should be able to understand refraction. I'm done. Go ahead.
Jesus. Okay. So once again, forget about the Earth. Just point a telescope at a star. The light that you have to point the telescope at the star. The light is coming from the star. It comes down the telescope. If it comes at a slower rate, it'll come at a slower rate. That's it. Because the only way it would make a difference is if the telescope is slicing transversely through an ether. And so if we saw some kind of deflection of the light, that would be evidence for an ether. Since we didn't see deflection, it's evidence either that there is no ether or the Earth is at rest with respect to the ether. It's that simple.
You say, forget about the Earth. So you're saying forget about the velocity of the Earth in this equation, which is literally
Earth doesn't have a velocity.
Stop. The velocity component to substantiate heliocentrism in the Copernican in Kepler's laws in Newtonian dynamics is 30 kilometers a second. So when you say the Earth, stop. Okay, so Kepler's laws don't apply. The Earth isn't moving around the sun.
There is no such thing as absolute velocity. That's one of the lessons of the Airy failure, the Michelson-Morley experiment.
No.
A velocity is only meaningful relative to something else.
Relative to the sun is the Earth moving around it at 30 kilometers a second to facilitate.
That's the way we like to describe it, but there's no way to know. You guys know yourself.
Stop. Stop.
What do you mean? You asked me a question.
I know it's more like a yes or no, very simple question. It doesn't require obfuscation and dog shit. Okay, that's what we like to think about it. No. You guys have very specific cosmological claims and velocities. Whether or not you want to, however you want to think about it, this is a dynamic falsification of the dynamics that are applied to the sky, where it's been told to us that Kepler's laws can be derived from Newton's and vice versa. Therefore, the gravitational potential between the sun and the Earth produces a velocity of 30 kilometers a second, which gives us the periodicity of the sun that we see, and the Earth is, and that's the Earth moving around the sun, right? This is what all of cosmology is built on. And then on top of that, they have measurements of stars that they say are deviating from their true position at a ratio that corresponds to 30 kilometers a second. So your argument now is that you don't believe that the Earth is in motion and that it's actually at rest. That's the relative
velocity.
Yes,
changes.
Because when you add water to the telescope, the velocity in the aberration equation changes. This means that the theta angle will also change. And what they didn't find was that there was a change to that magnitude. It stayed the same. Okay? So when you say there's no absolute velocity, blah, 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 that's fine. That's fine. But relative to the sun, our incoming velocity has been falsified now. Go ahead.
Okay, my turn. So when the Earth is moving in some direction relative to the sun, stars will be in a different will appear to be in a different position relative to when the sun Earth is moving in some other direction. But that doesn't mean that the Earth is moving relative to the star. All you have is the Earth and the star, and they may be getting closer together. They may be getting further apart, but there's no tangential motion that would cause any deflection of the light. Tangential motion, when you start talking about the motion of the Earth as if it's moving tangentially, you are implying an ether that it's moving relative to, or something that the light cares about. The light only knows that it's coming from the star to the detector in a straight line, and if it slows down on the way, it slows down on the way. There's nothing to deflect that light if there's no ether. And that was the whole point. Anybody can read about this in many different ways. You can watch videos on the Airy failure. The Airy failure was a failure to detect the ether.
Okay. So, dude, what you just listed at the beginning there, right? The position of the star changing, the aberration, that's optical. That's kinematics. That's a measurement. It can't tell you if the Earth is moving or if the sky is moving. That's why they introduced the water. I just read to you and it showed you the math. Nothing about this has to do with ether. That's not a variable in the component. If the light slows down in water and the Earth is physically in motion, regardless of what you want to make that motion relative to, it has to be in a physically different spot to correspond to Kepler's laws and Newton's laws and all these things. So if that's true, if it's physically true, then the angle has to increase. It has nothing to do with an ether. You need to show me where in these papers there's an argument about this being an ether argument. Okay? There's none of that. You've mentioned it several times and reiterated it. Just show me in Aries' paper where he says this falsifies an ether, there's no motion relative to an ether or anything like that. Because I just went over the Klinkerfues stuff, and you complained that it was too, they went on for too long or whatever. It was hard to follow, but it was pretty straightforward. I'm sure anyone here could steel man what was read. So you don't have to be obtuse about it. And when you say you can watch videos of blah, 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 like, bro, I'm looking at the source material, dog. There's no higher form of of authority than the actual source material. What do I need a video for, dog?
Well, I'm not going to appeal to authority. I'm just telling you in simple terms why the Aries failure was a failure to detect transverse motion of the Earth through an ether. That should be pretty simple to understand. If the Earth is moving transversely through an ether, then it's going to matter if the light slows down and gets dragged by that ether for a longer time. That's not what's observed. And so it is a failure to detect the ether. And there's lots of places you can read about that in much clearer form than
where are they?
Professor Klinkerfues or whatever that was.
Where are the places? Show me the links.
Just Google Aries failure and pick whatever you like. Just use a little bit of discretion in finding something that's good. I don't have one at
I'm on Google. I'm on Google. I'm on Google.com. Tell me what to type.
Aries failure.
Aries failure. Okay. We got Flat Earth WS. We got TS tfse.org. Where do you want? Where do you want me to click? Where do you want me to go?
Well, those will give you the straight poop, but I know you will dismiss them because they're talking to flat earthers.
Okay, this
even
this
though you find that
this I got you. So this, okay, which has, let's see.
There's plenty of things.
Hold on.
Stuff.
Hold on 1 second.
Well, why is it that you get to interrupt me? I guess because you're a moderator or something. Maybe.
Yes, yes, that's exactly why. And
okay, then I'll
shut up. Thank you. I'm glad you know your place now. So listen, we're looking at the flat Earth W thing, right? This is what it says. Airy's failure was an experiment which Sir Airy failed to confirm the ether theory by measuring stellar aberration, which proved that Earth's orbital motion. Okay. Let's keep reading. The ether hypothesis predicted that the water-filled telescope should be different. It should have a different value for the stellar aberration than an air-filled one. Okay. The change was not observed, hence Airy's failure, ruling out the ether. Stellar aberration in its annual shift of the position of the stars. It was first direct evidence of Earth's motion around the sun. Oh, no way. Flat Earthers claim Airy's failure is about proving the Earth's motion. In reality, it was the aim to confirm an ether theory, but it failed to do so. The experiment relied on an already accepted knowledge that the ether is in an orbit around the sun. The shift of the apparent motion of the stars, light from Lambda Draconis. Very cool. Okay, and we have here a little quote from James Bradley from 1777. All right, so what's being put forward here is that this experiment was about the ether. Now, when I go to the primary source material, which I just read from you, it didn't have anything to do with an ether theory or ether velocities or ether drift or drag. And what it had to do with was introducing a timing difference so that the angle would change, which would facilitate that the Earth is moving underneath it, and it's going to cause that. So we're establishing a cause and effect relationship by adding water. So when we have parallax and stellar aberration in air, we just have a measurement that can't tell us which is moving. When we do the water, that tells us which is moving. If there's no change, then the starlight already comes in at that angle. And that's all. That's the last I'm going to say on it. I'll let you get your last word. I'm not going to keep going back and forth with you, but you need to actually provide a primary source that backs up what you're talking about, because I've provided 3 so far. They all back up my position. You're appealing to a meme on a website.
Okay, so I'll just say I think most of what you said there was right. Certainly the things you read say what I said. And I agree with them. It's simple. It's, as I say, it's simple. To have a transverse velocity meaning something, it has to be transversely moving with respect to something. And it isn't. You just have a telescope aimed at a star, and the starlight is coming straight down that telescope to the detector. That's the relativistic view. That's what happens when you don't have an ether. But it's also, if you want, what would happen if the Earth wasn't moving. Now, the point is that it is the case that when the Earth is on the other side of the sun, it's moving at a different velocity relative to the star as well. So that changes the apparent position of the star. But between the two things, you still have light coming from the star directly to the detector. The Earth isn't slicing through an ether. And that's what the things you read on the web talk about. I don't know. I said already, I didn't follow the thing you read. It's not a primary source. It's not George Airy. It's somebody I've never heard of. Maybe it's somebody who was saying correct things. I don't know. I couldn't follow it. Maybe everybody else here is smarter than I am and could, but it sounded needlessly complicated, and it makes me think that it probably was somebody who didn't really know what he's talking about. Now, I could be wrong about that. Maybe it was just complicated and they need to spend more time with it. But the experiment itself is not complicated. It's what I said.
Well, I understood him pretty well. I think he was pretty on point. I don't know which part you didn't understand, but hey, that's cool. That's okay. Maybe you got to do some more research.
Yeah, I got a question for this topic, actually.
One second. I got a bunch to address here. Okay. So what we read was absolutely primary source documentation. As I explained to you at the beginning of this conversation, if you were listening and following along, you could participate in it rather than doing what you're doing now. So Aries experiment was done after Klinkerfues, who did the same thing and said that he measured the angle change. So I just pulled up Aries' paper here. He talks about this in the beginning, who Klinkerfues is and why he's doing it. Then he goes on to talk about the measurements and the results. And he says, I think myself justified in concluding that the hypothesis of Klinkerfues is untenable. Had it been retained, the aberration employed in the corrections would have increased by 15 arc seconds and decreased by 15 arc seconds in the latter part of the year, just like you were saying, where in relative times of the year and with the Earth's position around the sun, you would have, you'll be going towards and away from, so you're going to have to change the angle. And this position is untenable. What was Klinkerfues' hypothesis, right? That's where I went back to the primary source material, which you could find right here on McToon's website, mctoon.net/relativity. You could pull up Klinkerfues' translated documents where he goes over everything that I just laid out. So here's Toon's website. You can go here. I'll send you the link, right? You can get up to date on your primary sources. Oops, here we go. Copy URL. So here it is in the chat. Now, this is absolutely primary source information. And as we just read, it had nothing to do with an ether in regards to the ether being the dynamic cause or the motion being relative to the ether. This is independent of that, because the medium of water is going to introduce a timing difference. So if the Earth is physically in motion, there's going to be a change. You cannot escape that. That is a physical fact. You can't make it relative to this or that or do a transformation. And actually, you mentioned too that something about relativity when you correctly apply it or whatever. No, it doesn't predict no angle change. Relativity does predict an angle change, and I'll pull that up now. We'll look at the relativistic prediction for the angle change. And you're going to be surprised to note that it matches the classical prediction. So we have the classical prediction, which predicts that when you introduce water, the angle will be 27 arc seconds. We have the relativistic derivation here, which is identical to the classical derivation, except this has a little gamma factor in here. And I'm not going to go through the extended version because I already did earlier, but you know what the gamma factor is. This is a change in the coordinates x and the distance and time as a function of velocity squared over c squared. So this is an extremely small term. The first order term is the classical equation. This term is secondary, and it's actually going to be neglected here because when you math these out, what you get is a difference of 2/10 of an arc second. So they're completely identical because the gamma factor term is actually neglected. So relativity theory does predict an angle change, right? And then from that, because the angle change is predicted but not measured, what you have to do is then invoke a transformation where you assume the velocity of the Earth, even though you don't believe in velocities of the Earth relative to the thing, but you'll assume it for a math equation for a transformation. And I'm not saying you, because you didn't even argue this, but this is the mainstream narrative that's put forward for the explanation. Now, anyway, you take that velocity of the Earth and you transpose it into the incoming light and you say, ta-da, now the light has a horizontal velocity component and it's going to predict no angle change. So relativity now simultaneously, when using relativistic velocity composition, adding that little gamma factor to the classical equation makes the prediction for the angle change. And then you have to transform out of it by assuming the unmeasured velocity change in the angle. What the that's whatever, dude.
You're conflating aberration with the dragging effect that was expected in the Aries experiment. The aberration is the change in the direction, the apparent direction to the star from one time of the year to 6 months later. That's the aberration angle. In both cases, however, whatever the telescope is relative to the star, it points at the star and the light comes straight to the detector. There's no dragging for that light to be dragged with. If you put water in there, it just slows it down.
No,
I've said this many times. I'm done. I mean, if you don't follow, or if you prefer to follow what Alan's saying, that's fine. But this is a simple thing, and you can read about it on Wikipedia. You can read about it in a lot of places. I think the tune thing, I'm sure, I haven't ever looked at that, but I'm sure you'll find the same results there. It sounds like, from what I've read on the tune already, it sounds like Airy was basically saying that he disagreed with Klinkerfues. So I don't know. I'll have to look at that more. I'd never heard of Klinkerfues before. I was spelling it wrong at first.
You
I'll
also
take a
haven't
look.
read the Aries paper, though, because it's in direct response.
No, I haven't read the Aries failure. I haven't read the Aries paper because the experiment is explained in much simpler terms in lots of other places, and it's exactly. I mean, I assume Airy didn't disagree that he didn't detect a change in angle, and that failure to detect a change in angle was a failure to detect the ether that Airy was trying to find.
Yeah, no, it's a straw man. Maybe read Aries failure before making claims about what it's about. That'd be probably a good idea, right?
Yeah, and hold on a second.
I probably would, but if you can tell me that...
Hold! Silence!
For fuck's sake, just ask me to stop. I'm in the middle of talking.
Buddy.
You don't have to pretend that I interrupted you.
Buddy, if I'm saying stop, that's me asking you to stop.
Well, just say stop. Don't pretend that I was being a dick.
I was interrupting both of you, to be fair. Now,
I have to be fair.
Really,
it's pretty astonishing.
You keep saying that this is due to a dragging effect, right? And I gave you primary source information, and where you can find primary source information on what Klinkerfues' hypothesis was. Because the meme in Wikipedia that you are citing is strawmanning the position and the effect and the meaningfulness of it. Now, this was a Zenith mounted telescope. The telescope does not change its angle to put the star in alignment with it. So when they add the water, it's perfectly level. The water fills up the telescope entirely, so it's perfectly level as well. So there should be an angle change when they add the water, okay? And that should increase to the tune of Earth's velocity. If the first ratio in air is caused by Earth's velocity, then also there must be a change when you add more time for the light in the telescope. That's the whole purpose of it. So you saying I haven't read it and you don't know about it, but then you're simultaneously, dude, you need to get up to date on that so you can have a proper conversation and not do so much gaslighting and not following along. So, with that said, you can go ahead and get your last thought in there, but I don't think we have anything more to discuss on the matter. So I appreciate your time, and I apologize for the interruptions and the back and forth. And I know it got a little heated, but I've had some encounters with you before, and I was just trying to keep you on task and not let it go on and on. But thank you. So go ahead and get your final thought in, and thank you for participating. I appreciate it.
Once again, I'll just point out that you're conflating in the last thing. You conflated the aberration angle with the angle expected from the dragging. I mean, there is an angle expected from the dragging. When you improperly assume that the 30 kilometers per second velocity is a velocity through the ether, that's where that comes from. That's different from the relativistic and classical calculations of the aberration angle, which, as you pointed out, don't change that much. That's just a conflation of two different things. Beyond that, getting back to the actual what's expected from the motion in the water-filled telescope, I've gone through that over and over, and it's just, I mean, I've told you what's happening there. You disagree. I'll let people make up their own minds.
Awesome, thank you.
We have a question from the audience, if that's okay.
Yeah, go ahead.
If the star and the Earth share a reference frame or not? That's what he wants to know. Does the star and the Earth share a reference frame or not?
Nope. The sky is moving relative to the Earth.
I believe that was to the other guy.
Oh, my apologies.
Well, I wasn't sure myself.
No, I'm not sure myself.
I don't know
either,
what the question means,
so.
frankly. I mean, I don't know how to answer that. I mean, reference frames, you can have, I mean, they share lots of reference frames. You can look at them in any reference frame you want. Sharing a reference frame, I don't know what that means. Presumably, they're not moving at the same velocity. Presumably, the distance between them is changing. It would be unlikely that it weren't. And so they're not in the same rest reference frame. But I don't know if I'm answering the question, but I just don't understand it.
You don't understand what a reference frame is?
That's not what I said.
Okay, so in this situation, is the star and the Earth in the same reference frame?
Well, okay, I've already answered that question. I don't know what it means unless he's asking, are they in the same rest frame? And the answer there is unlikely. I mean, they could be, but it's pretty unlikely. You can use any reference frame you want, and they'll both be in it. But in each case, in each reference frame, they'll have some different velocity, right? One will have some velocity, one will have the other, relative to that reference frame, whichever you choose. Are they sharing it? I don't know what that means.
He means the inertial, he's saying the inertial, Heracles, you can come in and ask him yourself if you like, but he means the inertial reference frame.
Well, okay, once again, pick any inertial frame you want. They're both in it. In one reference frame, one of them will be at rest. In another, the other one will be at rest. And it's unlikely that those are the same rest frames, but it's possible.
John, can you steelman Alan's position about Aries' failure? What he thinks of Aries' failure?
Well, yeah, I think I have. I think that he thinks that the Earth has a transverse motion with respect to the light that should make the light, when it slows down, kind of get dragged one way or the other so that it would be at some angle. But that's really the ether argument. That was why the Aries experiment was done, was to detect the effect of the ether.
That Aries was done to detect the ether. It's just an egregious straw man. Like, the only reason you say that is because you haven't read the paper. It's really frustrating when you just keep repeating that. And if
that's possible. I mean, that is possible. Sorry.
Your primary source for that is Wikipedia and flatearth.ws. That's a garbage source. Why don't you read the paper?
The Aries paper.
Please?
Yeah. Okay. No, that's fine. I mean, I probably should read it. It's possible that the intent of the experiment was different because people had different ideas about things at that time. It may be that I'm interpreting it in the light of everything that we know now. So I'll concede to that. It's possible that I'm misinterpreting it, but it is the case that the Aries failure was a result of the fact that there is no ether or that the Earth isn't moving through it.
The experiment.
Yeah, but John, can you understand their frustration? You just keep repeating that talking point, and they're telling you to read the paper, which they just quoted.
SE, you're talking over Gal. You guys are talking over each other.
Oh, I'm sorry. I didn't hear. Sorry.
It's all good. It's all good.
The fundamental argument that this experiment was about detecting the ether, and my source is flatearth.ws or Wikipedia, and I haven't read the paper, but I know it was about this. It just sounds like a philosophical bias. It sounds like you don't actually care what it's about. You just want to say this thing over and over again. It's really frustrating. It's
okay. Well, I should probably stop then. I mean, I'm giving you an accurate reading of what the Aries failure meant to physics, but I will read the paper. I will read the paper and see what George Airy thought about it at the time.
Wow. And if you want an extension of that, maybe read Klinkerfues' paper as well, which it was in response to. He specifically addresses Klinkerfues' paper, which admittedly you hadn't heard of till this conversation, but you know so much about it and how this was all about the ether. And also your Steelman Abounds argument was horrible. He specifically said this is not about the ether, but then you referred to it as an ether argument. It's just it's really ignorant to come in here and just straw man someone so aggressively. And then also you gaslight the shit out of everyone in here where you're like, oh, maybe you guys are much smarter than me. Maybe I can't understand it. It's just like, it's full of dog shit.
Okay, well, maybe.
Yeah.
So
Galatrax, I want to say everything you said 3 times over. That's how much I agree with everything you said, Galatrax.
Yeah. So once again, I understand
Oh
that.
my God! Not once again. Not once again. You're going to repeat yourself
Okay,
again.
I'm gone. Never mind.
Thank you, John. Thanks.
I've been waiting to ask my question for 30 minutes.
Sorry, Riggs. I apologize, bro. Sorry.
Okay, that's okay. Look. I mean, I'm not going to say. I won't say anything more about. If there's another question, I'll stick around for it. Okay,
Yeah, we're
good.
done.
All right.
We're done.
All right, man. Okay, we heard your opinion. Thank you, John. All right. Okay, I'm just a simple man, Alan. This is for you. So you're saying that when light goes through a medium such as water, that it'll slow down. So there's a change in direction of the light. Is that correct?
There's a timing difference, and there's an apparent and then like the light looks differently because of that timing difference. So there's an angle change when you're looking at it from the side or whatever.
All right, and the light it would be the case that the light enters at the top of the telescope, correct?
Yeah. Yep.
Okay. So the reason I ask is because who cares about this ether idea? Because ether would be introduced possibly explaining stuff in the distance, and the mediums therein. But we're talking about the light going in through the telescope in that very moment in a very controlled area. So this isn't about ether as far as I can understand. Is that correct?
Yeah, that's actually specifically what Klinkerfues was laying out, because the physical implications using the laws of refraction and cosines, that you're going to have a change in relation to the velocities to make the prediction for the aberration angle.
Right. So are you saying that the telescope isn't the length of from the ground to the star? It's actually just in your hands as an apparatus on the ground?
Yes, sir.
So it has nothing to do with ether. Gotcha. Okay, great. So then I don't know what he's talking about, and it seems to make sense to me, and I'm just a layman, so.
I'm just a caveman. Your world of Lorentz transformations frightens me.
Well, thank you, Ellen. Appreciate it.
Yeah, no worries, man. No worries. All right, well, if there's any further questions or comments, feel free.
I think that was one of your best presentations. It was really good. Maybe I like the long ones.
Thanks,
As
Lee.
someone who listened to the entire presentation, I was able to understand what you were saying because I understand words.
Nice. I'd like to say once again, water makes a crucial role in disseminating the model. I love it. Water, the number one thing Achilles heel for their model, I think.
Absolutely, dude. And keep in mind, like I said, this is even entertaining a true position of a star and deviation therein, and assuming all these angles are the same ratio. Because when I look into this, they measure the angles. Sometimes they're a little less than 20 degrees. Sometimes they're a little more, but they have a specific value that gives them, 30 kilometers. So they're like super into it. So this is, even granting them the benefit of the doubt to step into their worldview to like fully explore this idea to see if it would give an explanation to the stars, and it doesn't even do it. It actually refutes it entirely.
Yep. Well done, bro. Another good presentation. And water again, water. It's so good. Such a simple thing, right? Can make the difference.
Dude, it does always come back to water, dude. Sometimes you lose sight of that. I certainly have a couple times, and then it's like you get into Newton's bucket, and it's like, oh, what's that? It's a bucket full of water. Uh-huh. You're like, oh, no way.
That's another one, exactly, bro.
Yep. All right, cool. Well, I'm going to wrap up the Prezi here.
Water.
Oh, go ahead.
Yeah, the simple stuff. Water, a rope with a weight underneath it, water in a tube, right? A water level. It's the simple stuff. Yep.
Yep. And the only way to argue against it is to straw man it and make it about things that it's not about.
And tell us we don't understand. That's my favorite one. You don't understand.
Yep. And if
yeah,
anyone
we don't understand, they don't understand, no one understands anything, right? Because that was his whole thing, is like, you guys don't understand what it was about. I don't understand what you're talking about. No one understands anything.
Dude, no one understands, but simultaneously he knows the answer to it and the meaningfulness of it. It's like, good grief, dude. Good grief.
Galatrax, your assessment of the whole thing with John was so spot on. Like, you said everything I was feeling.
Well, like, my issue is that he kept saying that Alan wasn't consulting a primary source, and his primary source was Flat Earth, WS, and Wikipedia. Because that's all, like, Google brings. The two Wikipedia results are, like, two anti-Flat Earth things that just strawman Aries' failure. The entire presentation was, like, I don't even think Alan said ether once. Maybe he did, but, like, it has nothing to do with that.
Only in relation to how it wasn't about ether specifically, and how there's no ether variables, nothing like that. So, and there's no dragging. Yeah.
I asked you, like, isn't this saying that it's independent of ether? Like, ether's irrelevant? And it's so stupid, man.
Yep.
Yeah, his tactic is to just keep repeating and repeating, his little fallacies.
It says here in my scientism Bible that that Aries' failure was about detecting ether, and he failed.
He failed to find it. Yep. All right. Well, I'm going to close out the stream. Thank you guys for tuning in. And if you want any of the sources or links to the press, so you can read it on your own or show it to your friends, the link is in the chat. All the sources are available on there. And if you need them, just ask and I'll upload any that you can't find. Oh, also, Lily, I'm so parched from that prez. I'm so drained. Do you know where I could go to get a good cup of coffee?
I heard Newton's got a bucket of coffee.
Newton's got his bucket full of coffee.
And it spins, apparently.
I sure do. I'm drinking a cup of Brushtail Colombian blend right now. And it sure helps me with my trying to detect the ether and failing.
Nice.
The bucket spinning, the water spinning, or you spinning?
All of the above.
Yeah.
All right, I'll be right back. Yo, shout out to the lads and lasses in chat. Hope you guys had a good showing of the Prezi. Thanks to John for coming out to do some back and forthing, even though it got a little heated. I got, not a lot of patience for being gaslit. It's one thing to say a bunch of nonsense, but to then, on top of it, gaslight me like I'm retarded is, runs right through me. So I apologize for being a little aggressive about that. I should have, been more patient with you. But anyway, see you guys on Tuesday for Dr. Michael Heffron. He's going to be doing a presentation on debate tactics and how to utilize the null hypothesis in an argument effectively. Because apparently we've been lacking in that department a little bit. So we're going to get some tips on how to improve our debate style. So tune into that on Tuesday. I'll have a preview thing up. And if you're not on Discord, guys, like, you're slipping. All the cool people hang out on Discord. After we wrap this stream up, guess where we're all going to hang out? On Discord. So join Discord. If you get in the verification process, just say that you're from the stream and you'll be fine. But all right, catch you guys on Tuesday. Peace.